Is my mic not? Oh, okay. Now it's picking up stuff. Okay. It was weird. It didn't seem to be for a moment, but I think everything is okay. Alright. First things first, I've got a few solutions that I can look through, so I'm gonna have a look at this. These exercises I've already done, and they're in my book, so prove that. Blah. B dashed got substituted in. Hold on. Yeah, B dash cross. Hold on, wasn't this 5 point? Yeah. I thought this was 5.2. Oh my gosh. Let me show you that it's this. These are way easier than what we came up with. Wait, this is 5.1 though, this is 5.2. I got to that same result, but I didn't note that T is a univector. Right, I forgot that the thing dot itself is the same as its magnitude squared. But that totally makes sense. T dot T is 1. Of course. That's cool. Hold on. So, what is it saying? How does this work? Differentiating this dot product with respect to T. You get this. It's just one of the properties. Oh no, he just didn't do the calculations to get to this one. Okay. So this. If T dot T is 1, then yeah, the derivative, which is just this strong, is equal to 0. So there was something. He didn't talk about the other ones. Okay, that's fine. Let's see, this one. Yes, this is the expression for B dashed. This, you simplify this as negative B T. And then you get rid of the negative, so that's up there. This one, BT cross T. Huh. BT cross T dash. So T dash. Huh. T dash he expressed as NT. Um. Hmm. So T dash is NT. Yeah, I tried to use that, but then what does this? BT cross NT is negative T. Hold on, because if B equals T cross N, then how do you hmm. Okay, let's draw this up. So I know B is defined as, is it cross T or T cross N? T cross N. And here he just said that B cross N. Hmm? Maths.
Just nothing specific.
Bachelor of Mathematics, Industrial and Applied.
Okay, I don't understand that.
Yeah, I can
What
message
do
it
you
to you
want
if
to
it's
be?
easy. Teacher. High school teacher. Hmm. Were your friends wondering? Mm. Interesting. Must be talking about me. It's a nice thought. Alright, so he defines he shows that this is this. How does this work? How do you play with cross products? Hmm. You like, no, I don't really know. Is it like, oh, I don't know. Like visually it's T cross N gives B. T cross N gives B. So B cross N. Oh, this is so hard to visualize. Oh, so B cross N. Oh my gosh, I'm trying to see this. So if you lay that down, then T is going down. Yeah, if you rotate this, it's B cross N is equal to negative 2. Wait, hold on, no. Right, hold on. If I'm projecting that, the B, wait. I'm trying to understand this. If you have the surface, okay, yeah, B going. Why did I project it that way? Okay, okay, yeah, this is going away from the page. This is going up, this is going right. Okay. Right, because n cross t gives a vector going up there, I think. I don't know, right hand rule says that, right? I always get confused about that. Or is it like... Or is it going this way? This way. Does it go this way? No. Hi, grass. Doshi doshi. Sushi so the su is she. Oh my gosh. Su is actually she. Su is equal to she. Hi, Hamburger. Hi, Polar Boys. Morning. Maybe use Paint 3D. Oh my gosh. Maybe. So wait, is this... Which way do these cross product? Show me. How does this... How does this work? How does this work? Is this maths? This is. So, A goes this way, B goes that way. Oh, okay, so it's actually T should be going this way, right? There. Towards and that way. So then if you lie this down, oh, then B is going in the wrong direction then. Okay, if you lie down B and N, right, you have... Oh my gosh, I'm trying to... My brain can't take this. If you lie down... B as this one, and N is this one, right? You get a vector... Yeah. Because this one's going this way, so this ends up going down, right? But I'm confused. I don't. Okay, so this is what the right hand rule says. Is that how you do it? I'm so confused. Oh, I see it now. Oh, I get it. So, like, this one was the one that I see. I'm like, well, how does that work? I don't. And the fingers curl in the direction of like the. I don't. What is weird? This one makes no sense though. Right, you do this one. A cross B. So if I draw it away and then towards, in a sense. Oh, it's away and then towards gives it though. Wait, but this one says it's... Oh, I see. Okay, so you can do it. You can do it this way and this way. Get this. Or you can rotate that and do it this way and this way. So they're the same representation though. You just rotated this. Still goes the same way, right? What the? What is this? A cross B is this one? No, you can't do that. You can't do that to me. It's so weird. My hand will use it in electromechanics later? Really? Working distress signals rescue corporations. It's like Among Us when the signal is SOS. The signal is sus. Always right until it's left and B is wrong. B, the other one is nunny. This left hand rule, it is always right until it is left. So wait, this is more like left hand, and this is right hand. Right, because if you did left. Oh yeah, this is left, right? And this is right. Me trying to figure out how works. So this one, is this one like, it doesn't matter in the application, really? I don't understand anything. Okay, so anyway. T plus N. So if I lie B down and I lie N down this way, and then I rotate them around. So I'm gonna end up with like B in this direction and N in that direction. Yeah, that's okay. I don't remember how crosswalks work. Okay, so that's the thing, right? And we get a vector going up this way. But when we look back at this, when we compare it to this, I get confused because I meant to see that this is negative t. I'm so confused. Well, maybe I'll make this one B and this one M. I think that'd be less confusing. That way I can see it directly. N. Okay, so B, so we rotated it, right? We took this and rotated it. And put it on the floor. I don't see where how this is T. You use the rule to see where induction electricity goes, whether there it matters. Oh, okay. Here it is as you like. Is negative T, try a line left and right. You'll see that B and N are opposite. Try to align the left and the right one. Did this one and this one? Yeah, I'm trying to work that out in my head. Like, how do you see that? Like, I need an object. With, like, vertices in these directions in order to see it. Like this is a projection of a box or something. How do you draw the rest of this part of the box? Where does this... That doesn't... How do you do art? Oh no, I'm not ready for the art stream yet. Would it just go across here? Oh, it would, wouldn't it? I don't know. It's because this is... Okay, so this is B, this is T, this is N, right? Then this is if I flip the box around so that... Oh, I see. I can rotate it twice, right? And then... Okay, I can flip the box over this way and then this way, right? No. Hold on. I can do this. I can do this. I can figure it out in my head, right? So you put it this way and then you rotate it this way, right? You flip it and then you rotate it. Then T is going out here. Wait, but then why is it negative 2? No, hold on. My representation is still wrong. Yeah, that looks like the T is still coming out of the box. Yeah, because T was always coming out of the box. Oh my gosh, help me. Wait, no, this is B and this is N, right? Otherwise it'll be... Oh... Well, how do... Boom. So, because, right, you flip this over, you rotate it. I don't know if anyone can see that. There's no way I can, like, ever demonstrate this to anyone, right? Can you see that? You can flip this box, and then you have, the top faces B and N, right? And this is T coming out of the page. I don't know how to represent that. This is T coming out. And then you rotate it. So then you get N going this way, and B going this way. And T is coming out of the page here. And then you rotate that diagonally a little bit, and then you get B here, and N there, and T coming out of the page there. Right. And then, from this, you can just tell that B cross N is negative T. As well. Like, I can see that. And that's how you visualize cross products. Actually, anyway. Wait, let's see. Hi Joe, welcome. You messed up the picture? Oh. Oh. Oh, for the second one, right? I did realize that this was written in the wrong order. So, try to do negative 6 on the left one and look if it matches. I don't even know what to start from. 3 visualizations, go, go, go. Because you drew it right, right? The right one is B and N wrong from crossbar. Yep, okay, now it works. What's the issue with using the right hand rule? How does it work? Do I have a right hand? Does it work with feet? Does it work with my hands? I only have 4 fingers. 1, 2, 3, 4. I only have 4 fingers. Does it work with 4 fingers? Yes, it does work with 4 fingers. um, right, arm rule does it? See, I'm still confused about this, right? So if you have N and T, but I don't see the relation between B and N. So, like, B and N gives a vector, but how can I tell that this vector is T? How can I tell that? Like, that's my problem with it. I see that if you have these two vectors, yeah, you can turn them around and do this thing. How can I tell? Is it my problem? Do a karate chop pointing in the direction of the first vector. Curl your fingers in the direction of the second vector. Your thumb is the cross product. Yes. Okay. See, that makes sense. Yes. See, that makes sense, right? That's still just. Oops. Yeah, that's what I've drawn here, isn't it? Oh wait, never mind. This is the one. Sorry, I drew this one wrong, didn't I? That's meant to go in that direction. We can forget about this one, right? This one? This is what it does. And I've just rotated it, right? But like, I had to draw a box to understand this as well. Is another thing. I couldn't see how they wrapped around each other otherwise. Anyway, my question is, how do you go from this to this? How do cross products work? I could probably just look this up, but how rearranging? Because see, my thing with it is like, aren't you like, don't you have to do some like post multiplication by like inverse of this or something? But it's a vector, not like a matrix. But they have the same properties, right? But I don't know. Cross product rearrange. How do you like rearrange it? Because I thought it would involve inverses or something. They're the same property. Yeah, okay, so here's my problem, right? So if you had B equals T cross N and you're looking to get we're looking for T by itself. So then you you post multiply by this one, right? To get like the unit one. But it's not, right? Unless it's a square matrix. So you can't do this? Like you can't do the inverses if it's not like a square matrix because it's a 3 by 1, right? So I don't think that any of this works this way, does it? Because then that's just saying t is equal to. See, that's what I mean. Like it doesn't work that way. I don't know how cross products work. That's the problem. Go ask my LA teacher. I have class in 30 minutes. No, I don't think. See, this is different, right? How do you rewrite cross products? How to rearrange vectors in a cross product? Okay, that's it. How do I separate the W and write in terms of V and R? What? It's not possible. I'm so confused. Unintuitive since it's not even associative? Oh no. Do you just have to... Does it have a way to rearrange properly? Can you just like... I should mark it. I don't know, I'm confused. See, drawing out all of this, definitely. A cross B cross C is not... Oh! I thought that was true. I forgot about that. I thought that as long as you do it in that order, rather, not from left to right, but keep them in that order, it would work out okay. But that's interesting to know. No, because then if you just do it in the other way around, then it's just a negative of. So it's not even an issue. But, no, I don't know. Alright, let's see this. Hamburger. The standard basis vectors I, j, and k satisfy the following equalities in a right-hand coordinate system. Oh. So it's just a sort of thing. Ij is k, jk I, ki is j. And then you can just, through, yep, right. So t cross n gives b. So I need to make sure that I know how this works. T cross b is n. No. N cross... What order does it go in? This, then this. Okay, so then n cross b is t. Okay. So this is just how you define the coordinate system. N cross b is t, and then b cross t is n. And then you can also just say that this is negative for when these are in the opposite order. This gives a negative. Right. And then from that, this one you can give the negative. Should I just accept that? It's anti-commutative and not associative. Are there more like... Are there other things that are like this, or is it just the cross product that's goofy like this? So I swear, this looks so weird. This looks like such a weird concept. When Matt's about the numbers, I don't remember Bruno. Welcome. Su equals she? Yeah, I don't know. It was mentioned. Su equals she. Anyway, that was, very... Yeah, since I didn't recognize that, I had to do a bunch of funky stuff to find a way to express, to get from b cross this expression to this expression. And I had to, like, I made some really weird rearrangements. But all he does here is, yeah, so it's this. And then he keeps that, and then t... Oh, then all he does is use the definition of what do you call it? Curvature? Right, and then, it's the curvature is magnitude of t dashed on magnitude of r dashed. Rearrange that, and then that just simply gives this as required. My solution's a lot more messy. It requires like multiple dividing by something and then multiplying by it to like get it as a leftover term. Some weird stuff like that. I additionally sent the explication matrix. What is that? Hmm. Would this help you determine like, because this is how you compute it, right? But I don't know if it necessarily gives me an answer to how everything. Hmm. Oh, explanation. Okay. Right. Well, thank you for your work, Cambodia. Yes, there is true. Okay. Interesting. I wonder what else does it then. You put three vectors into a matrix and use the normal cross product. Hmm. Oh, okay. Mm, fun. Vectors and matrices are the same. Of course. Everything is the same in the end. Alright, well that was another one ticked off. I need to check. So there's actually 5.1 and 5.2 that I need to check. That's so goofy. Well, no, it's gone. These odds are finished. 6 and 7. Need to check those ones as well. 5.3. So wait, did I not have to do... Oh, hold on a minute. I'm so confused. I'm... Hold on, I need to look at the time budget timetable. So you needed to do 5.2, 5.3, 5. Oh, you didn't even need to do 5.1. You didn't need to do 5.1, but I did 5.1 instead of doing 5.3. I did 5.2 though. I didn't do 5.3. Man. Oops. That's silly. Yeah, okay. Okay. Alright. Well, that's okay. Considering I did 5.1 instead, I would feel bad, but this is just here because it's on the same page. Otherwise, I would not have gotten a solution. This would be very confused, and that is a much nicer solution. I do need to. That's okay. All right. 5.3. Consider the helical curve in 3 described by the vector function. Blah. Compute the following. Verify that. So this is just taking the derivatives of this. R dashed is this on the magnitude which you write out. The signs and the causes explode. Okay, yep. Right. These two pair together, then you just get A as a result. A times 1. Or A squared times 1, and then B squared is its own term. T dashed is... Yep, same magnitude. Differentiate this. This is placing these terms on top of each other. Yum. BT is crossing these. Oh, hold on. Yeah, crossing these, right? Yep, computing that. Then use these definitions to compute that. B dashed equals blah. And hold on. B dash is equal to this with that. Oh, and then you substitute that in. These two expressions are equal provided that the torsion is equal to the... Huh, wacky. Well, that seems kind of gross. Oh well. Type E2 nani. I agree. As we're doing homework, double check that you don't have too much work. You got too much to learn, young Yoshi. Yes, evidently. 5.6. Wait, 5.6. Oh, I didn't do this one, because this is gross. Look at that. That's all question. 1, 2, 3, 4, 4 typed pages. No. No, look at this. This is ridiculous. Why would you make anyone do this? This is evil. Doing one of them would be enough. Why would you make them do all of these? Sheesh. Wait, this is just one of them. Solution. Yum, 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 yum. Oh, this one's nice, though. Huh. Oh, yeah, you're taking second derivatives, of course. You're taking derivatives with the derivative taken of this. Right. Because that's how you can write out your cross product. It's IJK. This first one, this second one. Yes. Okay. That's cool. That's cool. That one's actually kind of cool. Waste of time, like I said. Well, this one's kind of cool. The other ones are probably kind of... Okay, this one's probably the same sort of thing, though. Okay. Yeah, no, waste of time. You're right. Whatever. 5.7. Yes, this one was actually fun. This one felt good to do. We notice that f is not defined for z equals 0. F is C1 otherwise, yes. For z more than or less than 0. I didn't I just said when z's not equal to 0. I think that's fine, right? Yeah, to exist are satisfied for z not equal to 0. So then he does the whole process. His solution was x, the scalar potential x squared y on 2, take x sine z, take e. So y on z plus c, provided that z is not equal to 0. The solution exists for all x, y, z except plane z equals 0. Can I guarantee the same constant's valid? Yeah, and he told me that during the tutorial when I asked about it. Cool. Alright, cool. I'm happy with that. We have confirmed asked 3 check questions. Did I do any of the supplementary ones? Yesterday I did, right? Hold on, what did I do yesterday? Just 5.2, I think, yeah. So 5.1 was, given a curve, blah, express the following. We know that the unit tangent vector to a curve is defined as blah. If rt is the position along its trajectory, then t is nothing more than the ratio of the velocity of the particle to its speed. Express blah in terms of the local unit vectors t and t. If rt is the position, yes, right? It's a position vector. T is the ratio of the velocity to, yeah, the magnitude of the velocity is the speed. So we're saying that, oh, and then you use this result to write this. Ah, this makes so much more sense. So 8 is good. Hold on, which one was 8? Oh, higher, close. I could remember what was 8. 8 was good? Yeah, it looks like a similar, so it's neat. Okay. This makes a lot more sense. Alright, I'll probably show this next when it gets back to it. Take the derivative of this result to get AT, which is fine. Like, this is just using the definitions of a lot of the stuff at that point. Once you have this step done, like, once you have this, yeah, that makes a lot more sense. It's defining it. And the speed v of the particle. Right, and that's where he defined what v is. V will be the speed, and then you use that. Okay. Alright, you get acceleration. Well, this is the second of the 2 results we saw. We should also note. We should also note that dv oh, what's going on here? So the speed with respect to time. Is the derivative of the position, or the magnitude of the position vector. Oh, yeah, okay. Yep. Magnitude of displace... No. Okay, yep. No, it's the derivative, so we're talking about the speed, right? Right, speed v equals... How's that become this? How does this become this? Seems... of magnitude vanished. Like, this is just what is this? I don't... I don't know how you get from this to this. I am not seeing it. I don't know, I don't see it. Does anyone else see this? I don't see that. So what does he do next? He takes out the 2, that's blah blah. Oh. Is how you define r dash dot r dot dash. Is velocity dotted with acceleration on v. So you're resubbing v now. And this is apparently t dot a. Funky. Last equality is nothing more than what is implied by equation 1. The second last equality, interesting from the perspective of determining the rate of change of speed from the vectorial relation between velocity and acceleration. Statement that t is nothing, t really is nothing. Obviously. Equation 1 states that acceleration is a combination of contributions from t and n. It is interesting partly because of the absence of b, but also from the fact that acceleration can arise partly from an increase in speed in the direction of the trajectory t, and partly from a change of direction in the direction of the principal normal n, which is scaled by the curvature. The higher the curve's curvature, the greater is this contribution. A straight line has zero curvature, so there's no contribution to an orthogonal direction. Okay, right. These are defining... Yeah, okay, no, I understand now. So if one of the contributions is 0, then, like, it'll just altogether become 0 using this system. That's cool. From equation 1, we see that A has components in the t and n directions, while v is only in the direction t. From the vector product of v and a, we'll get a vector in the b direction only. Yeah, because you've used those two. From this, we can find that. Oh my goodness. Yep, so you're rearranging. Incidentally, b is this funky thing. The quantity said to determine is a torsion. This hasn't appeared, which is understandable since torsion is a measure of the curve's ability to twist out the oscillating plane defined by t and n. So far, there's only been v cross a. Some other kinematic quantity is needed. This can be provided by the rate of change of acceleration. Oh my goodness. Hello? Taking the scalar product of this result with b, and using equation 2, we get the torsion in terms of v and a. This can be negative or positive depending on the relative direction of the two vectors in the numerator. This last part is kind of... The first part was like, yeah, this is cool, and the rest of this just seems... Like that's fine, but like, ugh, it's still gross. So just to be a bit cleaner, the steps make sense, and I was right about speed cross T. Oh, so good. Oh, not cross. It's speed as a scalar. Yeah, of course. Speed times T. Yeah. Very nice. Okay, that's it's an interesting question, but like doing this myself seems absurd. Find the curvature and torsion. I only did the first one. I was like, it's not worth doing the others. Hold on, let me get mine up so that I can compare. Such a failure line. Luckily, I changed subject. Oh, what have you changed, Humberto? How have you changed in your lifetime? So this is what I got. 2 on root 19 and minus 3 on 19. Okay, let's find out. Required derivatives, the derived quantities, rather. Oh, he didn't even simplify. Wait. 2 root 19 does not seem to be equal to this, unfortunately. That's sad. This is minus... Why wouldn't you simplify this one at least? Minus 12 on 76. So I got that one right. I seem to have not gotten this one right. That's unfortunate. What did I do wrong? So I found out that this is the blah. You have... Oh, clever. Deriving each value and then doing the... Oh, that seems kind of smart. You plug them in and then you do the... That seems smart. That seems smart. This seems like a more functional way to do it though. Like this is kind of messy. And so you do the derivatives, you plug in values, and then you take like the parts that you need to plug in. So this part, this part, this part, and you get them individually as well. It seems cleaner. Alright, cool. No, noted. Good. Alright. The other stuff is just the same process anyway, so that's alright. It's whatever. Okay. There we go. We've checked this one. We've checked this one. Cool. 5 point... Is it? Ah, it's just because it's on the same page. But let's have a look and see what's on this page anyway. Yeah, we won't get to see the whole thing. Unless this is the whole thing. Suppose the smooth curve is to be parameterized specifically in terms of arc length, S rather than T. Ooh, that's goofy. Equations derived earlier express T, N, and B in terms of S. Derived formula. Oh, jeez. I called so formula and a fundamental to do it yet. In light of what is to come, we have explicitly distinguished between the coordinates x, y, z and their function dependencies on T. Oh boy. That seems like a thing. Morning, Arcania. Welcome. Am I hearing a Megalovania? It is, indeed. Probably just arithmetic? I'd imagine so too, but it was nice to see his process, his thinking. Oh, I need to talk about my encounter with him today. I'll do that once Zenix is around as well. I feel I haven't made the actual news yet. I'm going to do that after the cake. I'm back to being AFK now. No worries, no worries. We'll catch you afterwards. Did I show Zonix the thing I wanted to... Oh, do I have up? Was that on the Master Check stuff? I don't remember if it was stuff here that I wanted to show him or if it was... Oh, no, yeah, it is this one. It's this goofy looking funny thing that we were trying to work out. Yeah, I'll show it that after. Yeah, good luck. Alright. That seems like something. Verify. Oh my goodness. Fun. Like lots of fun. Firstly, terms of the very last equality contribute to the expression we seek. Terms within the parentheses need to be re-expressed. Ah, really now? Oh my gosh. Is that the end result? Exclamation mark! Nothing zero factorial, what? Go backwards, we readily discover. Mm. Which of the two contributions in parentheses items is thus established? That seems this stuff and this stuff ends up working out. Oh boy, that looks fun. What else? 5.11, but we also have 10. Verify. This verification is way nicer looking. How nice is this? See, that seems okay. Alright, cool, whatever. And then after this we'll be done looking through this stuff, and this is the sweet stuff. Show that in 3D a field proportional to this is conservative. Show that is solenoid. What is the... With divergence 0 at all points in the field. Hmm. So it's like it doesn't go into other planes. It's just in one plane. Okay, cool. Let's hold on. The ones I've written here are hold on. We're in week 9 as well, and I'm only looking at the stuff from week 9. Oh man. I need to get through this if I want to get ahead, because... No, hold on. No, I've watched the lectures for 10. Why don't I have those written as well? Oh well. I'll figure that out when I get there. We'll figure it out. Cool. Hope he doesn't forget to send us 10% of the cooking, 50% of the baking as in the company guidelines stated. I'm sure he won't, otherwise there'll be dire consequences. 8? Ooh, that was neat. C is... Right. And all with the magnitude of... Yep, so this is root, and then you're taking it to the third, so that's at times 3, so that's that. We seek a function such that... Hold on. Right, so that's such that f is equal to that same as the same thing. The gradient of some... What do you call it? Blah. What's it called again? Scalar potential. By inspection. Right, of course, if you take him with respect to x, y, z. Wait. This with respect to x. 2x... 1 times this, or blah, take 2x comes out times 3 on 2, take 3? Take 3 of this... I don't see this. This is what? How did you observe this? Hello? Is that okay? Yeah, I don't know how I feel about that one. Really? Is it really, like... Oh, no, yeah, okay, no, I think I get it, I think I get it. I think I see that. If you differentiate, that 3 on 2 obviously comes out. You get the 2x times half that comes out from this as well. Or negative half, rather. Right, 2x times negative half, x is there. The negative comes here. Okay, that's fine. By inspection, yeah, okay, U sub. U sub also makes sense. I can see it now, but I just can't see it myself. That's alright, whatever. Cool, I guess that's that problem then. I'll bring it to here for when Zanus comes back, because I think it'll be interesting to talk about. But, cool, this one's fine, right? That's fine. 5.10. So this was the one 5.10. 5.10. Hello. You here? Yes, 5.10. That's oops, wrong thing. Eee, you guys are legends telling me about this. Alright. Let's open up our paint. Trusty paint with our very beautiful vectors, actually. You know what? I'm saving this. What are we calling this? This is how cross products work. Okay, cool. Actually, I don't need this upper text, whatever. It's fine. I'm going to do my own homework now. Good luck, YoshiAus. I sent you a nice beam into the Discord. Let's have a look. Thank you for hanging out, though, Henboto. I appreciate it. Thanks for your company. This is a bit of puzzle game. I hope they release a new maths game for Switch soon. Oh my gosh, Henboto, you're a legend. You know that? You're actually a legend. Maths is definitely a puzzle of some sort. Is this high level though? I don't think I'm playing at a high level right now. I'm learning these concepts. This is like being introduced to the pro community. Like you're only just getting into the details of like the execution, right? Like figuring out how to parameterize stuff is like learning the inputs for really difficult combos and stuff. I don't know. Maths is the ultimate puzzle game. See, it's fun. I've always thought that maths is a lot of fun because there's so much like deduction you can do and that sort of stuff, and everything just fits together so nicely. But you know, it's also tough. Of course, made in paint, such as it should always be. Of course, I'm proud of you, Himboto. So good. All right. T-spins when? T-spin. I can T-spin. Hold on. I'm so good. Oh. Fill. Solid color. I said solid color. How do you... Oh, color 2. Yeah, there we go. Isn't Control deduplicate? Oh, is it not? Like something you can... What the? Why did I copy that one? You know what? It's fine. This is definitely a good T piece. Do you rotate? Do you rotate in paint? Rotate. What? Why is there another... Wait, where did you come from? Where did you go? Where? What? Rotation X. No. Interesting. There you go. Let's see here. Yoshi, you broke it. Paint doesn't like to rotate? I guess not. Or are you saying that in general? Like, have you had experience with rotating? Oh, it's gone! What? But, but, but. Uh, there. Done. Anyway, let's get back to work. That's a clip. Teases the brings reality. Gosh. When you select stuff and move it around, the background color becomes color too. It's confusing. No, my immersion's been broken by Bruno. Bruno's too smart. No, it's okay. That's cool. That's a nice thing to know. Thank you, Bruno. You're a legend. Alright, calculate the work done. So that's given by the line integral. Be sure that's what I determined yesterday, and that was right. So we are looking at... Hold on, let me get my notes again. Wonderful. Thank you, Bruno. Probably be good to post that one in the Discord here. See, this is why the math streams are still puzzle game streams, 100%. Now where are my notes? Bit farther back? I can't believe that before my physics notes now. Those physics notes, at least. One more forward. Here it is. Okay. Oh, so is this really just using what we already have? Oh, no, this should be written like this, hey. Should I have written... Because it's a vector valued function. Oh, I just wrote a big arrow over both of them. Okay. That's probably bad notation. I'll need to remember that. Okay. So let's take Diablo. What means vector? Yeah, so that is both. They're both. So this is vector valued, and this is like vector inside. Each one is a vector, sort of thing. I guess. Hold on a minute. If you. Oh no, never mind. Okay, no, that's okay. Minus sine t cos t and 1, right? So this is from 0 to 2 pi already given. This is... Oh, we need a... Hold on. So, do we use these, right? So you use R, and so that's what Y. Y is cos. No. It's use this one, right? So this is sine t, 2x. So this is 2 cos t, and negative z. So that's negative t, right? Dot. If it's as simple as this seems rather nice. Like a rather nice question. That's nice. Suspiciously. Oh, sorry, I should write that. That's dt here. Yeah, no, that'd be bad of me if I didn't write that. Okay. So then our result from the dot product is minus sine squared t plus 2 cos squared t squared t, take t, dt. Equals so sine squared is 1 take cos squared. So that's just cos squared take 1. Right? So that's 3 cos squared. Right? Sine squared is 1 take cos squared, so it's cos squared take 1. Yes, okay. Good. Do I have to use the funny identity again? Man. Cos identity. Alright. So it's 3 on 2 for this. And it's cos 2 plus 1. Okay, yep. 3 on 4, sine 2 theta. Wait, sine 2t, sorry. This is in terms of t. Three on 4, sine 2. Oh, you can combine these terms and just say that's 5 on 2. That's also good to know. Sine 2t. 3 on 4 sine 2t. Take half t squared. Plus 5 on 2t. 2 pi on 0. That seems right to me. With bad influence, here you are trying to study and do serious stuff, and I come and make you break the fabric of reality. That's basically the same thing, right? Studying is breaking the fabric of reality. Right? And then that's just... So sine just becomes 0 in both cases, so you're just left over with pi terms. Minus 2 pi plus 5 pi. Oh. And then everything zeroes out as well. So the answer to this one is 3 pi. Same. Huh. Do be kind of wonky sometimes. So maybe it's not worth rerunning the ones that we did here as well. I think we do need to keep moving. Because I would usually just write it in my book again, but which I did with a lot of the other questions. The ones that I was like checking today, I did write a lot of them in the book, so I can go through them with people. But honestly, I think this is pretty solid. Like, this was a pretty easy question since they defined everything for us already. At least I believe that's the correct process. It seems right to me. Yes, okay, this does seem right to me. Cool. Alright, well, we're gonna have to wait till next week to see the answer to this one, and what is it, 5.9. Okay, nice. Have a look at 5.11. 5.10 is done. Okay. Right. Okay, now that I know the shortcut, like, it's just a win. Okay, that was terrible. You know, I'll do that as well so that I know that this is 5.11 for sure. I can clearly see it. Right, we're new tabbing. This is hello. Let f be this. Determine a and b. What? Oh, so that f is conservative. Okay. Terrible snipping tool micro? Wait a minute. Oh, I have this in it. We're going to have to raise your APM. Oh, I'm sorry. I'll do better next time. I'm still learning. I just learned the shortcut. So please go easy on me. I am a, a, a poor soul, right? I didn't choose the snipping tool. The snipping tool chose me. Hope you understand my circumstances now. Alright, so we're saying that which one is it again? Which ones have to be equal? I think it's F2 with X, F3 with Y, something like that. Need to double check. Where is it? Here it is. F with Y. Oh, sorry. F1 with Y. F2 with X. Oh, that's right. They mirror each other. They mirror each other. Hi, Packin. Those are some weird-looking queer bobs. Yeah, right? They are looking goofy today. How do you do sad? How do you like? There we go. There we go. Green one. Purple is like green but diagonal. There you go. If my if my uni friends have to look at this. Anyway, no one will ask. Right, clearly. It's okay, we're training with Ringo. Yeah, Ringo. Look, she's right here. This is Ringo. There you go. That's Ringo. Hog Ringo training, right? So good. Alright, let's begin. So it's F1 with respect to Y. So that's 2 B, Y, Z is equal to so F2 with respect to X. Oh, sorry, F1 is with respect to Y. Oh, that's silly. Oh, F1 with respect to Y is just 0, so this will just be 0 as well. Yeah, this with respect to X is 0. Nice, so that one doesn't matter. F3 with respect to X is 2x on Z is equal to, and then this one will be with respect to Z. Yes, third one with respect to X. First one with respect to Z. Sorry. Numbers everywhere. So X on Z. And also, final one. Third with Y and second with Z. Third with Y is 3y squared. And second with Z. So that's by squared. Oh, okay. This implies that A is equal to 2. B is equal to 3. Wow, that was actually a really nice question. Hello? What the heck? Wow. Part A done. That was actually no, that looks like an alpha now. Oh jeez. Whatever. Nice. There's a photograph of Ringo Hondo on the screen. Crazy, right? Evaluate blah, where blah is the straight line from blah to blah. Ooh, okay. Hmm. Gamma is... Okay, how do you evaluate when you have... I need to double check this one. Line integrals. Tell me about line integrals. This, example 5.7, I think it was, right? Yeah, right. So you have f defined in x, y, z. And you have a path defined in x, y, z. Hold on. If it's conservative field, what can we do with it? Wait a minute. dx, dy, dz. What's going on here? What's actually going on here? Did I not find... Oh, I get it. Oh, I get it. So this is almost conservative. Is that what the trick is? Right, because this is 2x ln z, and then this is b is 3 in this one. But here they want us to evaluate it when this is 2. Oh, no, but the final term isn't x squared of z. Okay, no. Oh, why does that matter? Uh... What's going on here? Love finding unused parts of code. Delete button goes we. Wow, you've written negative lines of code today. Oh, incredible. No! Why would you do that to Bruno? Bruno doesn't deserve that. That's mean. Should we check if this is also conservative? Wait, what does this mean? This is... F is defined funny. Eating negative amounts of food today? Bruno, no! Don't do that. Why do you do that? That doesn't sound healthy. What did you do B? You probably have to prove that f is conservative with those values of a and b on the paper, not just in your head. Wait. Isn't this all that has to hold for it to be conservative? Or, hold on. Was there another thing I'm missing? I'm forgetting. Oh, give the potential function. Right. Right. Gotcha. I hand draw numbers. Indeed. And letters. Okay, right. So, do I have to go through that whole process? Or... So wait. So f is... Alright, hold on. Let's go back a bit then. Back it up a bit. Okay. F is equal to... Oh, is this the trick? And then this is gonna end up being that or something. Or, I don't know. We'll see. Hold on. So... This is... What, x squared out of that? Or am I oversimplifying? Oh, yeah, because when you differentiate with respect to z, you also get this. No, hold on. Wait, okay. I'll write it out first. Oh, why did I write b? That should be 3, that should be 3. Six... Y cubed... Z, does there need to be a Z here? Yes, right? And then with respect to... Hold on, Oh, yeah, this is it, isn't it? Hold on. Oops. We'll plus C. So, if I do this with respect to x, that gives you 2x ln z. Do this with respect to y, this disappears. You get 3y squared z. And here you have, with respect to z, so it's x squared on z plus y cubed. And that's it. That's it, isn't it? Woo! That felt kind of nice. How does that help us? How does that help us? This is part A. 5.11, right? Evaluate. Boo. Hmm, hmm. Where's the stuff in conservative fields? Because I... Okay. So this is also the same as writing that this is an exact differential. I remember reading that thing. I was still trying to understand that. Okay. Since it equals d phi. If f is conservative if blah is an exact differential. And that's where these terms come, right? 2x z is... How does that work? I don't think I understand that concept. What makes it an exact differential? The right-hand side of this equation is thus an exact differential. d phi is equal to... The idea here is that you can quickly calculate most of the vector line integral using the conservative vector field you just found. Really? Use this result. So, does this have to do with implicit differentiation? Is that what these, like, these end up? I don't... Because if you take this with... Because if I'm looking at this, right, I'm like, Okay, you do 2x ln z, and then you get a dx because of the implicit differentiation of like z. And then blah, this becomes 0 for whatever reason anyway, you're not like caring about these. And then this is 2y squared, which is like 3y squared z. But that's also implicitly dy blah. And this is plus y cubed, 2z, but then you're also not caring about ln z, like this term at all. I don't, no, I can't piece that together. Ugh. Oh, it's kind of chilly out here. I think gonna grab a jacket real quick. Be a moment. Gosh, I could really go for a hot chocolate right now, especially with like how much Zenix has been mentioning them lately. How does this work? Man. But the properties of the scalar potential. For it to be a scalar potential, its domain is of R. Oh, wait, hold on. Must be at least C1. The differential can be derived. Oh. Ugh. The partial. So just. Mm. Southern southern hemisphere. Yes. Uh, if because blood is a vector normal to the surface at R, the level surface is like what actual surfaces. I don't know what you do with them. Like this seems like very valid because my f is being given. Sorry, uh, my f is being given like this with dx dy dz. I'm like, what does that mean? How does that relate to this? It seems like this guy. Complicated way of saying that there exists phi such that the gradient of phi is f. Mm. Oh, oh. There exists phi such that the gradient, and it's specifically a gradient of like phi is just defined. It is just a scalar function, a scalar valued function, right? So if you're finding if you're finding a gradient of that, expressed as like this. Okay, I think I understand it better. Like you can find a value for the gradient at any given point on phi, in particular. Okay. 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 Got it. Got it. This is just if you have dotted it, you say. Okay. Let me next page here. Um, mm, it's clear your professor studies geometry topology. Is that right? Sheesh. I don't know what it got from this. Still. Okay, hold on. Back to the example. Maybe. Mm, Introducing differential forms in the first multivariate equals questionable. Ah, okay. So I have every right to be confused, right? An Oz-US difference? Maybe. So that's just if it's piecewise, right? Or is this different? Ah. Curve position dependent. Oh no, this is just if it's a set of. Okay. So, what in the world does this one mark? Integral. Wow. Determines the path along the curve. Parameterize r equals x, y is right. So x. Yeah, x t y is root 2. T varies from 4 to 9 because it follows x. And you can find that derivative as well. Yeah, and this is line integrals of vector value functions. Okay, that's that stuff. So this is just the Cartesian form. And okay. Alright. Alright. Let's write out F. Here. Y cubed. Okay. Right. What does that do? What does it do? You mentioned you can quickly calculate most of the vector line integral using the conservative vector field. Oh. Oh, so you can do. Okay. I think I understand. So you can split this up into two integrals, right? And you can use the part that's conservative. I think I finally understand. No, okay, this is good. This genius. Okay. So you can then split this up as the conservative part, right? Right, y squared z. Y cubed. Right. Plus just the single one left. Oh, wait, hold on. Should be 3, right? So is this minus y? Minus y squared z, so that you can get back, right? This is where the plus x squared z. Oh, this should be dx. I would rather dy. This should be dz, hey? Right? This part can be evaluated. Oh, I forgot the dz here too as well. this part can be evaluated using I remember it's just the endpoint take the start point, isn't it? Endpoint take start point. Where did I write that? I remember this. I was like, how do you use the conservative field? But yeah, just make some of it conservative, and you can find that path. Your hint was very useful. Use it to do most of the integral. That makes so much sense. Right, I'm pretty sure that plus. Right, x. Nice. Okay, where is it? Where is it written? Where did I write it? Right, it's the scalar potential. That's why you need the scalar potential. Oh my gosh, this is actually so. It's actually so cool. Evaluated at. How do I even write this? Can I like write the vector inside the function? Does that make sense? That makes sense, right? Where is it? Oh no, hold on. I need where it's evaluated in the straight line 2 1 2. So 2 1 2. Does that make sense to do? Take blah 2 1 2. This is 1 1 1. I'll deal with this after. I just want to do this part because I'm satisfied. This is cool. So you're putting in 4 ln 2. Hold on, we need the rest of that function. Plus y cubed, that's 1. Z, which is 2. Plus c. Right, these will cancel in the end, hey? Right, okay. Got it. 1, 1, 1. So this is just ln z. Oh, that's just 0. 1 plus c. Oh my gosh. Oh, hold on. This is just part B, hey? So that's 4 ln 2 plus 1 plus a bit more stuff. And then all we have left is this, right? We have f is... Let's like make this f dash or something. So this is 0. X squared z. X squared. What's that? This is a neat problem. I'm so happy to like see things fit together. This moves along path 1 1 2. How did they... Okay, so in this case, we can see y gets kept constant, and then x moves with z, right? So it makes sense to say, to parameterize this as... How do you write? Equals... No, sorry, r, for this one. I should probably right. Draw this in different colors so that like I don't get confused. And very big so that I can see that this is where this is pointing. That doesn't look like much of an arrow. There we go. That looks more like an arrow. Beautiful. There we go. Wonderful. Alright, back to this. So our R is then defined. No, hold on. They're calling F this, right? No, then they sub it in, okay. So... It's a Ringo. She got turned into... she's helping us. It's for a good cause. She is helping us. Okay, so R is T is 0 T and T is 1 to 2. Woo! That's good, isn't it? Sell my time right now. For a limited time, you get 30% of my time for voice chat for free. Oh my gosh, yo, that sounds great. Let's do it. I'll take you up on that. Oh, wait, hold on. Do you mean in voice? Actually, I should have probably checked if you meant in voice first, but... Hello.
Hello.
I should have checked if you meant in chat or in voice, or...
Oh no, I meant this.
Okay, well, I guess everything is okay then. Ooh. Would have been a bit awkward otherwise.
A little bit.
So...
I am doing 30 minutes here, then I'm gonna go make the noodles because I just need to be off my feet for a little bit,
yeah.
and then I'll come back and like chat more if you're still around.
Yeah, sure, sounds good. How's everything going?
Alright, everything related to ramen is going really well. I'm very happy with how everything has turned out so far today.
That's awesome.
I'm obviously yet to make the noodles.
Yep.
Broth is amazing. Like,
Ooh.
probably the best broth I've ever made.
Oh dang, that's a big thing.
Like,
that's big.
I tracking down a whole bunch of pork bones the other day. Like, did it. Like, yeah. Pork belly seems amazing. I haven't like cut it yet because you don't cut it until the next day. But it like I tore a little bit off because it's very tender and it tastes good. Eggs seem to be going well. What else have I done? Oh, the tare is great as well.
Oh my gosh, everything's
All
good.
I have to do is make the noodles and some oil tomorrow.
Woo woo.
But oil doesn't go in ramen. We let that from old mate.
Obviously.
Like cake on the other hand.
Cake
is delicious.
Ooh.
It's not quite done yet. Like I've tasted bits and pieces of cuts.
Okay.
I've just put the like mirror glaze on it, and I'm waiting for it to set, and then I get to like cut it so it looks pretty, hopefully. But I think I put like 15 grams too much oil in it, and it's very crumbly, so it's very hard to move.
Ooh. Okay.
So it was meant to be a 4-layer cake. I was meant to make 2 like 4 centimeter-ish high cakes and cut them in half.
Okay.
I cut the first one in half, went to pick up like the top of it, and it just fell apart.
Oh jeez.
So I did a jigsaw and put it all back together with a bit of ganache to like try to hold it all together. And we'll see how it actually goes. It's not a pretty cake. It's not a pretty cake, but it tastes good.
Okay.
Every
that's
component
important.
of it tastes good at least.
Yeah.
Yeah. The aesthetics can be worked on later. Like, good reason there was a test case.
Yeah.
If I have someone else to give another one to, I might make a second test one.
Ooh, that's exciting. Very cool. Sounds like everything is going good.
I think so. It has been a fun day though.
Oh, that's
I was up at 8 o'clock, and it is currently 11 o'clock, and I've spent maybe 2 hours out of the kitchen.
Ooh, okay. And like, it's just been fun, huh?
Yeah, it's so good.
That's good then. Awesome. So good to hear. And you obviously enjoy this a bunch too, which is why you spend your like time away from it doing this as well.
Oh yeah. I definitely didn't want to just talk about the like day of cooking.
Well, I wanted to hear about it anyway, so it's fine. It all worked out.
Good.
As long as the pictures are taken as well. That's important.
So I haven't taken many pictures yet today. I will take a photo of the cake soon.
Yes, okay.
Assuming it's set tonight, otherwise it will be taken tomorrow. And I will take a photo of the pork before and after I cut it. There's nothing too special about the broth, like
Yeah.
in terms of looks.
Oh yeah, fair,
Except
fair.
curry.
Yeah.
Like I'll take a picture of the finished product there too, though.
Yeah, sounds good. Excited.
Yep. All right. How with
Uh,
math?
yes. Okay. So this question that we were really confused about, it makes a bit more sense now.
That is good.
Yeah. So he wanted us to write it with speed v of the particle, right? So you're expressing everything in terms of these vectors, but you can write those vectors as. So this is what it's defined as.
Hang on, I don't understand the problem still. What are
Okay.
we trying to do? We're trying to write.
Express the position, velocity, and acceleration in terms of t and mb.
Right.
Okay. Yes.
I think I'll understand as we go.
Okay. RT is the position.
Yep.
That is just how writing equations works. And we have a definition for t
It's just the derivative of that.
on
Over
its
magnitude.
magnitude, right?
Yep.
But since we're trying to define position, velocity, and acceleration in terms of these, then you can note that the derivative of the position is the velocity.
Right.
And then the magnitude of the velocity is the speed.
Yeah. Right.
So that's how you write that.
Right.
Or
Right.
rather, well, this you rearrange it, but then that gives you your velocity. Then you differentiate this to get your acceleration, which makes a whole lot more sense.
So this is actually way easier than what we're trying to make it out.
Yes, this makes a lot more sense. Like, seeing it makes a lot more sense. I would never have thought of doing this, but like, it's a cool little exercise, I would say.
Yeah.
You do that, you
I'm
find
gonna
the
put that
speed.
down to badly worded question.
Yeah, honestly, I'd say so too. If it gave any guidance as to like what, that's the thing, right? Like, I think all of these questions are just like, do this, and no further explanation on like where you go with it, and it just leaves you lost and confused.
Yeah.
And then you could just do something completely not right at all. So even just like a nudge in the right direction helps you know where to go.
Yeah.
And then it's just a whole bunch of like rearrangement and stuff to get the other one. So that's cool. Fine enough question. Question that I'm doing right now. Actually, I have it on my paint. Let f equal this. Determine a and b, so that's conservative. So we checked our things and we're like, oh look. Oh wait, no. It was this. This is our blah equals blah blah equals blah blah equals blah. And it was really nice actually. It was just a equals 2, b equals 3, which is cool. So we have this is conservative when it's this, and this is a scalar potential because we can use that in calculations. And then I was like, how does this help with this? And I said, I was here for a little while, and Joe was like, you can use this to help you do this. And I'm like, I don't see the connection. Do you see the connection?
Hang on, let me.
I was, so I can tell you the answer if you don't see it. But I was like, this is so cool.
No, I don't see it. I don't think. I'm not going to see it like quick enough. I don't think.
Yeah,
There's
so
something to do with derivatives going on. I think.
oh, okay. Well, this is just another way of expressing the line integral. So you could just pretend dx, dy, dz don't exist. That's just taking like line integral.
Cool.
So these components go to each of these, right?
Yeah.
With like extra stuff. So what you can do is you can split this integral up into two, where one is known to be conservative, so you can find that part out really easily, and then you just do the other part.
Yeah.
And
That's
so
cool.
I was
That's
like
the even odd trick with integrating over thingamajigs.
yeah, right? Symmetric or whatever,
yeah, there we
right?
go. Symmetric things.
Yeah, right? So then I'm
Things
like,
with symmetric compounds.
yeah, so you have this, oh, whoops, that is the select, but
That
you
is
can
a
do
really
this,
cool trick.
and then, you know, this is all you have to do if you're taking a line integral of a conservative field. As long as you have your scalar potential, which we've already written out, which is why we needed to do it, you just, it's only dependent on the start and end position of the path.
Yeah.
So then you do that, and you have this term, and that's like super easy. And then all you have to do is work with just a little bit of the integral left. So I'm now just doing the parameterization, and that seems right to me. I think. I hope that's right. When
That is pretty cool.
the parameterization is R, right? Like from yesterday? I don't know if you remember. Oh, that's okay. I hope I'm doing this right. So this is from 1 to 2 of f written in terms of t now. So this is right. It is a really cool
Oh.
question though. This is super cool.
Yeah, it is. It definitely feels like an analog to the symmetric type of problems.
Right? Definitely. 0, 0.
What was I gonna say? Oh, I sharpened 2 knives today as well, and I finally used my whetstones.
Oh.
One's like $10 Kmart knife because I had no idea what I was doing, so I was like, if I screw this knife up, who cares?
Okay, yeah, fair enough.
And I sharpened the oldest knife I had, like oldest half decent knife I had, because I barely use it anymore because it's way heavier than all my other knives, and it's just like a pain to like use like for long periods of time.
Right.
So I was like, if I ruin it, it's okay, I guess.
Right. Yeah.
Like, I don't. My life is not going to drastically change because of it.
Yes, that makes sense. Your parameter doesn't go through 1, 1, 1.
Correct.
Wait, this is a 1. It's a 1. Whoops. Right, that's alright. Gosh, I can't. There you go. 1, 1, 1, 1, 1, 2. Wait, that was what the path was. 2, 1, 2. Sorry, 2, 1, 2. Yes. Okay, that's good, right? Thank you for that. So this should actually be minus t. 0 minus tt. Dot with t. Oh, the derivatives of this. Which is 1, 0, 1. With respect to t. This is 0, 0, t. Oh, this is just t. I always do the brainless parameterization. Oh, okay, that makes sense as well.
Yeah.
Yeah, right. It's the same sort of deal though. Cool.
Mathematicians don't like to think.
I mean, this was like the easiest way to look at it for me. So I was just like, these are the
Yeah.
same. And it goes from 1 to 2, so you just make t go 1 to 2, and they're the same. So you just, I don't know, it's nice. Oh well. Brains think differently, I guess. Alright, almost there now. Plus half t squared. Whoops. Plus 1 plus 2 take half is equal to 4 ln 2 plus 3 take half is 5 on 2. That's our answer.
Nice.
That feels really
definitely on
good.
Joe's side. But you do you.
Instead of having a generic parameterization of a line between 2 points. I don't know, it felt more natural to, like, just say it goes from 1 to 2.
So what would happen if they were the same?
Then
So
I
what if
don't
that
know what
second
you
two
do.
was the 3?
I don't actually
do
know
what
what
Joe
you
did.
do. You do what?
You do what Joe did. So you just take the direction between the two and take the first point and add it to t plus the direction.
Oh! Oh, I see. Right, so you're setting t between 0 and 1 for every...
Yeah.
So that's how you parameterize this r
A line.
for given points. Okay,
Yeah, it's just a line segment.
that
Sorry,
makes a
no.
lot of sense.
For a line segment, yes.
Yes, okay. No, I understand now. Now that I have that process under my belt, now I know how you parameterize stuff. That makes sense. You go from first point, you add t, you say it goes from 0 to 1, and then you just make the second point. Whatever the stuff inside the t, the vector, is the difference between these two.
Yeah, that's right.
Okay, good. T0 is starting in T1.
wonder
Yes,
if-
that makes sense.
Have you done anything with convexity at all?
Convexity? I don't think so.
Yeah, like have you... Interesting. I wonder if you're like... What you see changes after you do convexity stuff. Because like you always care about lines in the space in convexity.
Huh. I see.
And it's always in the form that Joe wrote, basically.
Okay. Well, that's fun.
When do we get to parameterized surfaces?
That'll be coming up soon, I suppose, because if we get this through this,
Yeah.
then this is the all the stuff on line surfaces and I mean line integrals and stuff, and then we're doing surface integrals.
Oh, did you watch any of MHL stuff?
Not just yet. I think we'll have a look after I'm finished with.
Yeah, no.
Yeah.
I just didn't know if you watched it beforehand.
Ah, nah, haven't watched.
Yeah, so much time saved in the tap games.
Very
And-
curious.
AI games. Because he's 4 minutes at 400.
4 minutes at
Chucky way.
400. Hello.
Yeah,
Are you kidding?
I only watched the first game.
But it was
Yeah.
in 8 games, right? So he actually just got the MM exam
Yeah, he must have got the MM exam.
on the
like,
one
first
on
game.
3. Yeah, I could have done that. Well, definitely. It just didn't. 5.11. That's it. Wow, that's so cool. So I think I have a pretty solid grasp of this line integral stuff.
That is good. I missed it all.
So if you have an almost conservative field, then you can just take out the stuff that doesn't make it conservative and then evaluate that as a different integral, I assume. Stan was going on about like, oh, almost conservative fields
Yeah,
are
I
very
remember
useful.
reading that in the book.
Yeah, right? He was like, make a note
Or
of that
maybe-
because it could be useful at some point. And then I was like, how is it useful? And this question literally just like answers that question. I think that's super cool. How nice. Alright, that's all the mastery checks. Let's head on to the supplementary. See what line over there. Actually, is that another imaginary task on? Or is that a normal task? I don't remember what this is from. I'm losing track of time. All the numbers are everywhere. It's like tomorrow I have probability, which is tutorial 7, which is topic 11, but it's week 9.
Yep.
And it's like content from week. I don't even know if everything's everywhere. Most conservative isn't exactly a strict definition. That's true, but he mentioned just if something looks slightly off. It's like the much less than, right? It's like that isn't very well defined, is it? Well, for the times that we've used in class, it's the limit.
Yeah,
thing,
for the
isn't
times
it?
you've used it.
Yeah,
It's a limit.
I know it's a limit thing, but like when we've used it in class, so that wasn't also well defined either. So I don't know. With this class, there are a couple things that aren't exactly the most well defined, but I just roll with it because honestly, it just makes enough sense.
Like, there's lots of good heuristics which are not well defined but work out in lots of practical cases, or lots of cases you come across.
That's fair enough.
Like the integration by parts rules about like what the thing you integrate and the thing you
Oh,
differentiate.
yeah, right. There is like a set of. It's sort of
Yeah.
more like a recommendation, if anything, I suppose.
Yeah, or like
in
if
practice.
you see a circle, go to polar coordinates.
Yeah.
Except
Oh,
that one problem we had.
yeah, right. The one.
It was the
It may
intersection of
seem
two.
like it, but it'll make it really hard. Yeah,
Yeah,
there's
well,
2 cylinders intersection. Oh my goodness. But then it works for 3. So funny.
Yeah, if only we were given 3 cylinders, it's easy.
Yeah. So funny. Alright, this was ended up being a nice looking question. Okay, so if I finish this supplementary stuff, then I will be able to move on to stuff ahead of time, and then I can feel confident moving on to the next couple lectures as well, finishing off the last 2 weeks of lectures, so I can then just do the assignment.
Yes.
And then on stream we'll do physics, I guess. I guess.
Yeah, that's a stream I may not tune in.
I don't know. I feel like you're basically obligated to be around now.
Yeah, I think I am. What day will we do that? Because I am out tomorrow night, obviously, and I'm probably playing board games Friday.
Tomorrow, if I can get through this, then yeah, tomorrow I might be able to spend doing just lectures or whatever. So, or I might finish off. No, I'll need to do surface integral stuff. So, we'll see. We'll see.
Cool.
Not sure yet. Let's go to 500, 300. Hold on. There we go. Supplementary 304. That's the one. Supplementary 5.
Tracking back to food.
Mhm.
Despite cooking lots of really good food today,
Uh-huh.
I have ate like offcuts of cake, little like dips of fingers in melted chocolate here and there, and a couple of like frozen pastry thingies that came out of the freezer.
Lots of
Just
stuff.
like I haven't ate any of the good food. Like-
just a funny range of like bits and pieces of.
Oh, and I've ate some
Right,
toast.
right.
I ate some, yeah,
Toast.
toast for dinner. Yeah, I ate the
Nice.
like pastry thingies. Like I didn't even know what they were. They were probably like ricotta and spinach. Pastry thingy-majiggies. And some toast for dinner. Toast with like honey my cousin like which is really cool. Like I love
Okay.
that honey. It's so good.
That's good then. Still good,
Like, honey
just not
straight from
like
the hive.
crazy fancy food, I suppose.
Yeah, like the food itself is fine. But
Yeah.
definitely not the like same quality of ramen.
No, definitely not. Alright, so the supplementary ones look nice. Looks like we're just doing a couple of
Bruno, these are
fine
ones
enough
free recording.
exercises. Okay, yes, so this is some courses. Okay, 2 of my courses. This one, multivariable calculus and applied probability, they all have pre-recorded lectures because they were all stuff from last year and the content hasn't really changed, and he was like, oh, it's fine, we can just give you recordings, which is, I mean, fine, but, you know, not preferable. With linear programming networks, we have one Zoom lecture, and then we actually get the other lecture in person because it happens right before our tutorial, so it just makes sense to do that on campus as well, because otherwise we'd just be on campus anyway watching the lecture, and then we go to the tutorial. It's like the same amount of people, so why wouldn't you? So those ones are in person, and then the physics ones are all online, but the physics ones are like kind of conveniently during the days where I'm at uni with my friends, so we watch those ones, like we book a room to watch that lecture online but together, so it's easier to bounce off ideas and stuff, which is definitely helping me with physics. I think it's just good for everyone as well. It's good. That sounds like a pain. It is like all over the place, and it, like, I still have questions about 6 hours of lectures during this 1 week for one course, and usually there's just 3 hours. Like, how did they do 6 hours in 1 week last semester? I mean, last year? Or did he just, like, organize them really weirdly? Because some weeks also have only 2 hours. I just don't understand.
Yeah.
It's weird. These really kind of
Bruno's-
naggy students. Teacher constantly what's the... Oh boy.
Some of those students are great, some of them are so annoying.
See, I think Bruno would be cooler.
It depends on the questions asked. If it's the
that
student
way.
just trying to flex their knowledge, it's so annoying.
Okay, yeah, fair.
But if it's like the student trying to understand, it's like good.
Yeah, right. Fair enough.
Like, yes, I know you know more than what this course has. Why are you even coming to the lectures? Just annoying me.
Yep, there we go. Yeah, absolutely. That's good. Oh,
Yeah,
right.
yeah. No,
Our-
I'm totally happy with those questions.
Our encounter with Stan today.
Oh yes.
So we were like, okay, we're gonna go ask him what his hours are. So we figured, okay, why don't we just check his door, like what? Because his office was listed on the course outline.
Yep.
So on our way back from a class, we were like, okay, so we could just take a detour and go to his office. We got there and checked the door, and there was nothing. Unfortunately, the contact hours weren't listed. And then he walks out because he's
He
heading
walked out?
home. So
Oh, he walked out.
yeah, he walked out at that moment when we're all standing out his door, and he was like, "Oh, hello," and we asked him about his contact hours and stuff, and he was, I don't, it's weird. Like he even said, he was like, "Oh, I feel like a bit intimidated with all these students." I'm like, is it like because you haven't had enough like face-to-face contact? Like you feel scared of us? We're not doing anything. We just need help. Like,
We're just waiting. Help us.
right? And it's like, I think maybe he was also concerned because he was about to go home, and we're like, gotta hold him up or something.
Yeah.
But now we asked him, got because he seemed kind of like, I don't know. Again, it could just be because he was intimidated or whatnot. But he pretty much kind of expected that, like, we didn't know about his contact hours at all. So, which is kind of weird. Like,
God damn it! I've been trying to hide these for so long.
yeah, right. Which is the weirdest thing because it feels like he would enjoy the contact, and like we would, but he's also so hesitant that it's, I don't know, it's weird feelings. But yeah, now we know
Yeah,
that he's
well,
on campus and
it sounds like
available.
he's the kind of mathematician who looks at his own shoes, not the other person's shoes. I've
Yeah,
told you this
who knows?
joke, right?
No, no. What is this?
Oh, how do you tell an introverted mathematician to an extroverted mathematician?
How?
The extroverted one will look at your shoes.
What?
It's about being socially awkward and stuff and looking down all the time.
Okay.
The introverted one will look at its own shoes. And the
Right.
extroverted one will look at
That
its
makes
shoes.
sense. Um. But yeah, we know he's around on Monday, Tuesday, Wednesday mornings now, so we can just go see him during that time if we need to, which is nice. It's good to know those hours and stuff.
Dan, it's 8 a.m. Monday. Let's do it.
I do wonder how early he means, but we wouldn't be coming in on a Monday morning. As much as I'd like to demonstrate my enthusiasm for multivariable calculus, I think 8 a.m. Monday would be too much for any of us.
Yeah, 8 a.m. Wednesday was a bit of a pain.
Yeah.
That was like lecturing something I enjoyed.
No, just early starts at that. It's kind of. Know what the list of contact hours are for the most part? Yeah, right. There we go. It's in my uni. They completely ignore that. That's silly. How old is he? He's.
Well, like, if it's the same as my uni, it's ignored in the positive direction, as in like, yeah, I don't care when you show up. I just like have to list them.
Yeah, that's
So,
fair.
days and show up whenever you want. Basically. So
He's like 50-ish or 60-ish. Because he mentioned 20 years he grew up here, 20 years in Sweden, and then he said he's been back here for a while. So like we don't exactly have a number on that. But,
41.
yeah. He only just got back. Amazing. So funny.
Well, depends on your definition of a while, right?
Well, he's been around for a while. In terms of he's taught here for a couple years. I know that. But then
Yeah,
like
these notes are definitely not just written notes.
yeah, no, absolutely. So he's spent some
And
time.
you've got pre-recorded lectures from last year. Yeah.
Yeah, exactly. So you know. Some teachers that would literally
Yeah,
impossible
those
to get contact
teachers
with.
that are literally impossible to get in contact with suck.
Yeah.
That's the worst.
Blech. Physics guy has been cool though as well. We've also had some fun interactions with him. There's a guitar that lies at the back of his office. And you know he picked it up to demonstrate some stuff to talk about sine waves and everything. And my friends and I just we were watching the lecture. We're like, what if we asked him to play it? So like with every passing
his
lecture, his name is David.
Yo, David, play Wonderwall.
He mentioned that he's like learning to play it, but he's also like he has so many hobbies and he's done so many things. Like at the start of the first lecture, he was talking about all the things he's done, and we're like, whoa, you're crazy. He has like,
I've
so
played
many random
Tetris and
hobbies.
Play-O. And I'm like, I play Tetris.
That would be great.
I get to mention bowling sometimes too. Bowling's good.
That's cool though. Yeah. But yeah, we've just like nudged him a few times, and today, like just during our tutorial today, we were just like, yo, can you play the guitar today? And then he said, okay, you got me. I'll play for you before the end of the semester. So that's something to look forward to from him. He's a cool guy though. Like interacting with
How
him
old
has
is
been
he?
pretty fun too. I have no idea how old he is. I'm really not sure. Doesn't seem
Is he close
so old,
to
but
your
like
age? Or stands?
he's definitely
He needs
been
to-
long enough to know, probably like 40s.
Oh.
I would say so, because he's done so much stuff. He's been a whole lot of like a billion things.
Yeah.
So you know, maybe. For sure in class, that'd be amazing, right? So good. Time I had to prepare a presentation about competitive playing Pokemon for uni as well. The subject was dumb anyway. That sounds very fascinating. I wonder what the subject was.
I made my students try to connect 4 engine.
Yeah, see, that's cool. Cosmetics is cool.
It was actually pretty cool. So, like in terms of trying to hit both academic and real world stuff.
No, that's good then. That's the best combination. Install a Moodle. Oh my goodness.
Yeah, I had a teacher like that.
That's
Alright, you guys are gonna write a wiki on topology. It's like, god damn it.
Okay, so our R is, what do you call it? 0 to plus
Enjoy your lunch.
T 4 minus 2. I'm doing this right? And then T ranges.
No, you're not doing this right.
What?
It's not a straight line.
What?
It's a semicircle.
Oh, this is the path. Oh, so I can't just do this.
So you could do that last time because it was a straight line, right? Plot out. So this is where I think a drawing's gonna help because it's only in 2D.
Okay, yes,
Plot stop.
perfect.
Oh, it's actually a quarter circle.
Hold on. Because y is only positive, hey? So
Hang on, that's not even a quarter circle, is it?
wait, is this just a curve like this?
There are missing.
No, 4
squared,
is 0. 3, 2, 1. That was very good.
No, there's not a missing squared there. X
0,
equals 0. Y is 2.
3. That's 1. 2. That's root 2. So it is just like a thing. That goes up like that, right?
There's an intersection at 0, 2.
Oh. Wait, hold on. So it's along this path, but 0, 2. Oh, of course. Okay. Wait, hold on. Zero, 2. Okay, right. So it's a curved path along this, of course. Yeah, alright. I can use my brain answer. So...
Perfect.
How... You just set y equals t and then rearrange for x? Y
Is that going to
equals
be easy or the other way going to be
t squared equals 4 take x. Therefore, x is equal to 4 take t squared. That seems
that
fine,
was
right?
definitely easier.
Because otherwise you end up
Yeah.
with this root.
Yeah.
So this is parameterized as t and 4 take t squared.
Or
And
4 take
t...
t squared and
Yeah?
t. 4 take t and t.
4 take
T
t...
squared.
Wait. 4 take t... Huh?
So just set y equals t.
Oh, yes, other way around, right?
Yeah.
Okay. T 4 take t squared. And then this ranges from 0 to... Wait, so x ranges from... Wait. 2 to 0? 0 to 2... Hold on. How does this work?
0 to 4. No, hang on. Is that right?
Wait,
No,
this is
that's
going
not
in
right.
opposite directions. Hold on, did I rearrange
Yeah,
this wrong? T squared is equal to 4 take x. X is equal to 4 take t squared. That's right,
No, that's
isn't it?
plus, right?
That's a plus.
Hang on.
Ow, what have I done? T equals...
No, yeah. Goes from 2 to 0. Cool.
Okay, yeah, I figured it was in the other...
Should I go that back?
Yes, thank you. Right, okay, so it goes from x goes from... Right, x goes from 0 to 4. Y goes from 2 to 0. Yeah, I'm trying to like look at draw triangles to like see where this goes from here to here. But yeah, that makes more sense now. Thank you. Perfect. Yeah, right. So you could just negative these and then make it go from 0 to 2 as well. But I mean, whatever. It is whatever.
Not a big deal, just a negative sign 3 hours later. Where's this negative sign going?
Yeah, honestly, that's that. Yeah. So the x squared.
Multivariable calc? Yeah.
What is?
It has multivariable calc.
Oh, I thought you said watts, and I was like, that says house.
Yep.
Okay.
It said house.
Wonderful.
Check the board.
Wonderful. And this is x squared. Oh, it's gone well though. I think things are making sense, and you know what? I will take that. Things are making sense. How are you doing? You can hop it in again.
Next semester.
Hmm?
See if you can remember multivariable calc next semester.
Oh, surely. Right, that's take 8t squared plus t squared, which is 7t squared, plus 16. And this is just 0. Right, we also need the derivative of this. But we can write the integral now. Sure. This is from 2 to 0. It's the dot product of this and the derivative of that. Just minus 8t. Oh, minus 2t, sorry. 1. So, we end up with... Oh, since there's a minus here anyway, we can take it out and just go from 0 to 2 now, with it cancelling, which is nice. That becomes 2t to the 5. Take 14t cubed plus 32t. They're not the nicest numbers in the world, but sure. Equals t to the 6 on 12? No. 3 on 3. T to the 6 on 3. Take 14 on 4, 7 on 2. T to the 4 plus 16t squared. 2 and 0. So our final result is 2 to the power of 6 is 64 on 3. Take 16 times 7 is 112 on 2. 112 on 2 is 56. 56 times 3. 56 times 3 is 168. Yeah, that A is not nice. Plus 464. 64 times 3 is 192 on 3. And that result is this is 192. 256. 256 take 168 is 88 on 3. Assuming my calculations are right, this is our solution. That was nice. I'll take that. I'm happy. I think I'm getting the hang of this. I'm like so scared to say stuff like that, but it feels good to just like look at this and be able to just solve it. Like that felt really good. Very exciting.
That was quick.
Right?
Speedruns.
That only did take like 10 minutes.
Oh, speedrun final exam live. Oh.
Hey, if the final exam is going to include line integrals, I'll be happy. I don't know why the assignment
Really
didn't include any line integrals. It's weird, because like the assignment is just all surface integrals, it seems. Which is weird. Well, come on, really? You have one triple integral, and then 3 surface integrals. Why couldn't you just make one of them line integral?
Well, Joe will be happy.
Alright, let's save this one. Which one is this? Oh yes, SP 5.15? 5.15. SP 5.15. Nice. Alright, next one. 5.17.
That's how numbers work.
You said you what?
That's how numbers work.
Ah. Yes. Well done. I'm a math student. I know how numbers work. 100%. Alright. Oh, okay. Along the x-axis and then along a parabola. Alright. Cool, cool. It's just the same process. Just doing it again so we can get good at it and faster at it. Okay, so for part A, it is just a line, so I can do the funny method. And just say that R is minus 1, 0 plus T. What is the difference between that and that? That's 2. Shush. Okay. That's his. Oh, no. No. I swear I know how to do this. Cool. So if that's f, of course. F is 0 as its x1. And then it's y, which is this is just 0 anyway. Y, what? Huh? Is this just 0?
What are we? I have no idea how we calculated F last time. What are we doing? Oh right, F's that thing in there.
Wait. Isn't y 0? I thought y is 0. Hold on, what happened? What happened here?
Yeah, no, y is 0.
This is 0. I think the obvious parameter is it. Are you kidding me? Does that make it work? That doesn't make it work though, right? Because y is still 0. So this is just trivial.
I guess so.
This is just 0. Oops. All 0. B. Okay. Now we're doing it along this parabola. So we can set x as t then. Y is equal to 1 take t squared. So that's R. Lovely. F is 0. Let's see, 1 take t squared, 1 plus t. Right, 1 take. Yeah, okay. 1 take t squared, 1 plus t is 1 plus t take t squared take t cubed. There we go. Yes, okay, I'm not crazy. And our integral goes from...
the crazy.
Oh, wait, t goes from... What?
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 Litmus test for being crazy and not being able to correctly do that.
Oh, jeez. Hold on a moment. Wait. No, hold on. This feels... minus 1 to 1. Minus 1 to 1. Yeah, okay, of course, because otherwise y would be 1 at a certain point. We're not looking at it. Looking at this. Okay, cool, cool, cool. So we're going from -1 to 1. Oh, and we know it's symmetric, so we can just say it goes from 2 to 1 and then have 2 because we're that cool. And then it's this. Dot. Derivative of that is 1, which doesn't matter anyway, but it's 2t. dt is 0 to 1 of -2t of this, so we can just reverse the order now because it's nice. 2t cubed. Take 2t squared. Take 2t dt. That's a lot of 2's. Take that out. 105. T to the 5. That looks like a 6. 104. T to the 4. Take 103. T to... Take 102. T squared. 1, 0. What's the common thing between all of these? Is it 60? It's 60, right? I think it's 60.
Yeah, is that a 3 or an 8?
Oh, that's a
Surely
3. Let's rewrite that. 12 on 60 plus 15 on 60. Take
Yeah,
20 on 60. Take 30 on 60. Equals 27. Take 50 is -23. -23. So 23, that's 92 on 60. 92 on 60 is 46 on 30. Which is 23 on... Hold on, I forgot what my denominator was. No, I need this again. Oh my gosh, of course, you can just cancel the 4 and the 60 from the very beginning. You don't have to do all that. I should know that. 4 and 60 is 1 and 15, and that's it. That's how you get rid of the 4. Alright, cool. Just leave it as is and answer the answer. That's true. I just wanted to do some maths in my head and do some numbers because numbers make sense to me and make me feel like I'm accomplished.
The students who flex.
1.
What?
Ah, yes, my... I know that was very random out of context. But that was also when I stopped tomorrow.
Oh. I didn't hear any German.
It was my dad, not my sister.
Oh, what do you speak?
What do you think?
Swiss.
Okay. I don't have to confirm or deny anything. You can just come up with what he speaks. So what does it mean if this is negative? If the line integral is negative? Does that just mean it's traversing a path that's in a negative region or something?
Oh.
Well, it would be, hey, because it's along... Oh, hold on. No, I don't really understand.
That is a Joe question.
That's above. The work is negative. Huh. Oh, so it's just moving in the like negative direction with regards to what we're... Okay. That's fair enough.
Alright, I am going to go make the noodles. Well, the dough for the noodles.
Sounds good.
I will leave myself in this call. Alright, I'll be back.
Yep. So this is just saying there's no work done. That's funny. Okay, yep. Makes sense. Cool. And that's Ooh, one more. Alright. 5.20. Ooh, this one's a bit funky. Although I wonder what... the other ones are here, because these ones are actually evaluations, it looks like. And like, could be helpful. Okay, so this is all line into stuff. So there's only a couple others. Anyway, we'll focus on getting this one done. Oh, I cut off the integral. I can't deal with that. That's silly. There we go. Yeah. Compute blah, where A is blah, and gamma is a circle in the plane x equals y, with center 110 and radius 1. Hi Ruth, welcome. Not really good at math, so I guess I can watch this. Feel free to chill in here. We like to keep the vibes comfy. Let's see here. Circle in the plane x equals y. And they give us a picture as well, don't they? It's such a funny circle. Thank you for the follow as well. Much appreciated. You know what, may as well. Yeah, well, that's a bit funny, isn't it? There we go. Yeah. Hey, it's the Ringo theme. Alright, that's for this. Okay. Why is a circle? Ah, that's what she says, doesn't it? Isn't it? What does that actually mean? Is that her lose quote? That's a lose quote, right? What does it mean? Maybe I'll find out later. To redo or to fix. Oh, oh! Now is to fix. So did they use de as a like exit? Is it the exit de? Actually, you know what? Let's just show this real quick. Quick break. Oh yes, we're already here. で、直して、を、ではな、をする。で、直する。To make a fresh start, turn over a new leaf. Oh, it's su. Ste. Yes, okay. It is this day as well. De nas. Naos. And this was the one I was thinking about as well. Cool. Yeah, exit and like you leave to go fix it, like to try again. That's cool. De naoshite kimasu. Yes, from Kudu. Kimasu. So Kudu makes sense as well. Cool. Yeah, same there, same now, same Kudu. Very nice, very nice. That picture's misleading. Oh, what? What? What's wrong with it? What's going on here? So it's traverse counterclockwise from 100. Wait. Why are there like a billion things going on? What is this phi? What is the point of this phi? Looks like it goes to the origin, but it doesn't. Oh, yeah, okay. Right, no, that's fair. Yeah. No, because then it would have to go through the plane, wouldn't it? It only hits the z-axis, right? Because if it has radius 1, and, Oh, no. Hold on. Yeah. Oh, no. This is the plane, right? Oh, so it does go above and below. Right, okay, but it doesn't hit the axis. Oh, rather, it doesn't hit the origin. Okay, cool. No, good to know. Yes, because this is just basic trig, right? Like, it wouldn't, this diagonal would not be of length 1. Yeah, square root 2 away. Yep, that makes more sense. Cool. Because this is 1 here, and this is 1 here. But because it's... yeah, okay, cool. No. Good clarification, thank you. Mas. Cool. Cool. Bruno being cool with the little Japanese insults as well. Actually, I need to grab some water. I'll be right back. Back. We are back. Just give me a moment. Actually, hold on. Need to check on something else as well. I'll be just another. Okay, sorry for the wait, everybody. I'm back now, though. Uh, this week's Wednesday meme is a kid yelling big chungus in a Walmart. Nice. Hey, Waffle, welcome. Can you say my name for a follow? Waffle 180? Incredible. I have no idea. Maybe the chance has passed. Maybe it's too late. It probably was too late. That's okay. That's not what I'm here for anyway. Such a random thing. And also Kirby with a knife. Ah yes, Kirby with a knife. Classic. He's done it. I did it! Yatta! Isn't that just incredible? Alrighty. Let's get back into this. So, we are dealing with... I like keeping standard with stuff, so we'll just say that F. Oh, no, we will parameterize those, right? So we're doing a circle with center 110. It's... Hold on. So it's... What? So you... Oh, so you start here and you're going around, is it? Is that what this is? So counterclockwise is seen from 100. Wait, but if you're here, then... No, I'm confused now. Because this is right to you, so then it's this way, isn't it? I'm so confused. I don't actually understand where it's going. Doesn't matter where you start as long as you go all the way around? Okay. Fair enough. Is that a thing for like when you have... When you have gamma being closed? With any... So... I suppose with each of these questions, it makes sense to always check for conservativity. Is that the word? Probably, right? Conservativity. Because you know that a circulation of a conservative field is 0. And it probably just won't end up being as simple as that. But for like the previous questions that I've been doing, should I also have been checking for conservative, like it being conservative or almost conservative, so that I can simplify the integral? I think that would make sense, eh? So it makes sense to me. Not a bad idea? Cool. Cool. So this is minus y. I've been writing it this way. I think this is fine too. When it's only dot product, I can write it here like this. Usually easy enough to quickly confirm there's no potential function. Okay, yeah, makes enough sense. Right, I need to remember what the relations are. 1 and y, right? 1 with y, x with the second one. It's here. Yeah, 1 with y. So this is minus 1 is equal to... This is factor... Yeah, no. Meow. right? Oh no, that's 0 anyway. No. This is with respect to y, and this is with respect to x. Yeah, okay. Cool. So just from that, we can see that it's not conservative. Cool. Yeah. Yeah, because if you took anything with respect to z, it would just be 0 anyway, and that would mean a lot of these would have to, like, everything would have to be 0. But it doesn't work that way, as we can see. Okay, no, that's good. Good, I suppose. Good thoughts. Alright, in that case, if you're... Hmm. Does this require writing out... Ooh, hold on. Thinking about this. Hmm. Oh, okay. I think I understand now. So you can write out the equation of a. I don't know if I'm overcomplicating this, but you could write out that the equation of the circle is x squared plus z squared equals 1, right? Also, or rather, it's not x squared, but it's x take. Then you get a really messy thing for z, wouldn't you? Because I'm thinking like x equals t, y equals t, then z would equal from the circle equation. Does that work? It's actually an ellipse in the xy plane. What the heck? Morning, Shocky. Good morning to you. Ellipse in xy plane. What? xz. X. Oh, yeah! It is, isn't it? Yes. Okay. Yeah. Think of what it goes through in the xy plane. Just x equals y, right? On the xy plane, right? It's kind of traced out for us here, right? It's moving along x equals y from 0 to root 2? No. Rather 1 plus root 2, hey. Oh, but that's intuition, right? So I shouldn't really be. Or circle touches 2 points in the xy plane. 2 points in the xy plane. Hold on. Wait, so xy plane is defined by z equals 0, right? And we have... we have... circle... Buh. How would you work this out normally then? Z equals 0 for... a circle defined how? I don't know how you define it. Because the equation of sphere is just like x squared plus y squared plus z squared equals blah, right? That's a sphere. Oh, but then you're saying z equals 0. So then it becomes... Oh, then you get the equation of the ellipse from that, right? Right, so because of the fact that z is equal to 0, it then just... Or rather, it's not x, it's x take 1, right? X take 1 squared. One. Because the plus z squared becomes 0. Hi Tetu, welcome. Haven't gone to calculus yet. Do get to it soon though. Sounds fun. Early calculus is super fun. What do you know, wait a 45-degree army. See, I figure that makes sense, but like, if I wanted to, I guess there's no one way to solve this problem, but I guess if that's the sort of, we talked about that being the whole, we talked about that already, right? With it being root 2, right? Because if you draw out the triangle, or rather, hold on. One root 2 with triangle. Where's the triangle that we're drawing? Wait. Hmm. What is my trouble with it? I have a way that lets prioritize these, but I think it's the way your professor intended. That's fair. Thinking. Hold on, I'm trying to figure out in my head why it's not. So the radius is 1. What? But it also goes in this direction. The circle goes in this direction. But it's not like... Oh, man. No, okay. Yeah, obviously. Okay, no, this is 1. This is 1. And then this is 45-degree. Yeah, see, I was seeing that triangle, and then I lost it for, like, a bit. And it just didn't make sense. Suppose then it's root 2, 1 take root 2 here. Or, hold on. 1 take root 2. And then 1 plus root 2. And z equals 0. Whoops. Well, it would be 2 times this path. It's a bit dodgy, but use angle phi as a parameter. Yeah, I figured phi was in there for like a particular reason. That's fascinating. And are like travels along here where phi varies based on the angle that this xy line projected up onto z. That seems to be in terms of cos and sine of phi. Oh, is this just implying a spherical transformation then? Because it takes that style of... I only just got used to how cylindrical coordinates are implemented. I never got... I never really tried to see how spherical worked very well. So I don't know the way that, like, phi and theta vary. Oh, no, but he only indicates a phi, not a theta, so... Just a phi. Okay. Hold on. It is just... Oh, it's 2D anyway. So you would only need, like... Okay, no. Right. I'll keep thinking. I'll keep thinking. Immediately we see that z equals cos phi. Okay, that does make sense. That does make sense. Because z, like what I was saying is that it's drawn up from this plane is drawn up to the point where the circle is, and up is cos. just how it works. Hello there. This one's a bit funky, but Joe's being helpful. So.
Cool. I am slightly distracted. 2 seconds.
No problem. Hold on. Yeah, so phi could also be... Wait, no. Phi... This is the same over here, right? And then it's... Wait, why is it cos? If it's this angle. Wouldn't it be cos if it's here? Or am I thinking about something? Isn't this sine? Because wouldn't cos be here, so this is sine. Oh, it's adjacent. Oh yeah, right, of course. It's adjacent. I got them mixed up. Yes. Yes, right. It's this one's adjacent. This one's opposite. I was thinking of cos as opposite, but it's like, no. Yes, thank you. Thank you. Perfect.
Fuck, he's awake.
Yeah. He is. So then oh, so if that's all that Z does, then X and Y simply vary along a line, right? Is that it? No, it's not like that, is it? No. No, it feels weird because all the... Because I can see it as just, you're moving along this path, but then up here Z is doing all the work of changing that path, right? But it is just a line at that point. So it feels like this is just... How does this apply to X and Y where... like, I'm only seeing this picture. Uh, okay, so because I was talking about this being sine, does it make sense to assign this here as sine? Why does that make sense though? Why does it make sense? Because x and y... How does that how does that influence? R gives us the set of points in blue. We can represent any arbitrary point in the circle in terms of phi. So at this point, Z, the or rather, is it is it 1 take sine of phi? Because you start at 1, then the x and y vary along this line drawn out from 1, not from the origin. That was my mistake, right? It's not from the origin. It's drawn out from here, the center of the circle, which means you're tracing you're tracing this distance here. You're tracing this. Yeah, that makes more sense. This distance makes sense because it's from here and it varies based on phi. As phi increases, this then follows that and it will get longer. So it makes sense that this is phi. So here it's 1 minus sine of phi. Then over here it's... Oh, but if you want to trace out the whole path, you can just go 4 times. 1 take sine of phi would just be this whole segment there, hey? And we can use that distance to determine x and y. Oh, you use it to determine x and y. I thought you would just define it as that. Because, like I was saying with the whole, like, this then projects down here, right? Doesn't that give us... Oh, no. That gives us a... I see the issue. Because then you have to map it back to x and map it back to y as well, right? Or, like, trace it back to get points for x and y. So, if this is... Okay, so this is here, right? Which here is 1 takes... One take sine phi. How do...
I wish I could point to it that sums up online and learning.
What?
I wish I could point to it that sums up online learning quite well.
Is it... Huh. Hmm. How... Okay, so let's say we're on this side, because it is 1... Sorry, that's not 1 take sine, but that's on this side anyway. Right, so if you're here, then you have this. and you. Right. Okay. Let's draw this. Right. The hypotenuse is 1 take sine phi long. Length is sine phi, which is right. Which is the hypotenuse of the triangle. 1 1 0. Oh, this point is 1 1 0. X10, XY0, X10, XY0. Oh, the length is sine phi. It's not 1. Oh no. Oh no, it is just the. You're taking it from. Yeah, no. You're not subtracting. Oh. I'm getting there. No, I was thinking it was 1 take because that's what I was trying to. I was trying to set x and y as 1 take sine phi. That was my thought. That's what it was. I was considering a point, which was 1, and then you take away from brain. No doubt telling my regions, but I'm back sorta. Welcome back, Bruno. Goal is to find the coordinates labeled by X on the diagram that converges of dollar lines. Right, and then you can use that to define the path, is it? Okay. Okay. Thank you for this help, by the way, Joe. Hi, Andy. Right, okay, so... Maybe I should try out this way because it's easier to recognize it then. So we're saying here that x then varies... x10, xy0. Why is it... x10 and xy0. Hmm. This y-axis is x-axis. Hi Gail, thank you for the host. which is the hypotenuse of 110x. So this point here is defined as xy. Oh my gosh, of course. Yeah. This point here is defined as xy0, and then this is... Ah. My gosh. I'm so sorry that it took that long for me to realize. So this is drawn out here. And this here, this here. So you could go between any of these, right? But we're choosing to set y as the constant. Oh no, we're going up here, aren't we? If we're going this, if we're setting y to be the 1 at 1, then 0. Oh, hold on. x1 0. Because y is 1 at this point. Right, it's... Wait.
Let's channel your inner Euclid, Joe. Just the diagrams or anything. Look out the construction.
Just know how it works. Just...
Oh, that's a you job. Joe clearly knows how it works.
Not being able to annotate makes communication challenging? Oh, absolutely. Did you hear that they added calculate and switch? Really? We already had Mario Maker for that.
Lucky I feel that.
Yeah, brain confused as well. Would this be like 1 y0? Hold on, I'm trying to figure out why it's 1. Because this doesn't necessarily map to... Oh, are you just drawing a triangle? Is it more like this? Oh yeah, and you're trying to find this point in terms of... Oh, okay, no. So the triangle goes back here, right? Or if you're considering this, it goes back here. So it's one of the stuff that's not on the diagram. But this is something we're analyzing ourselves. It goes back there, or it goes back there, and then that's along 1 for the given variable that we're tracing along. No, it's really dumb, but why not consider plane x equals y is another axis? I mean, I don't think it's dumb. I just wouldn't know how to work with that. Hold on, let me wipe my glasses. Oops. Okay, there we go. That's the way I like to think of parameterizing it. Oh, that's interesting. So wait, okay. Okay. This here is 110. This is xy. 0. And this here this point here is x0. Oh, sorry, x10. And we know that this distance is sine theta. We need to destroy all of this. And move this. And then we have x take 1 is the distance here, right? If that helps at all. Question mark. Or 1 take x. Oh, no, it doesn't. Those also consistent. Why? This is 1 take 1. The circle gamma is same as the function x take square root 2 all squared plus z squared equals 2 something y equals 0? Huh. Um, what do I do with this? Why do we get the value of the line score by using the shadow of circle gamma? That's what I was thinking earlier. It seemed to make sense that z varies upwards using that gamma, right? From the pose. And then the rest is just a line, so then that just varies as question mark though, because I still don't know how that relates to the other two, unless that's the line width. I mean, that's what we're going for, right? Because we're just finding these endpoints now, which seems to make sense. Just not seeing this. um. Vector r dashed of oh my goodness, hold on. I'm trying to interpret this. R dash shadow vector in either y, z, or x, z. Oh. Is that the ellipse we were talking about? It would end up forming? Was it? Square 2 and 2 by magnitude vector r. Sounds interesting. My brain is not taking us in.
It is past midnight.
True. But this
And
is...
I am not being helpful in the slightest.
It's okay. This is one more question. And then I'll leave it for the night.
So we're just trying to find the point x, y?
Yes. In terms of this phi.
Yep.
I'm still not seeing it. I'm not sure if you had any idea of
Nope,
where
I
to
haven't
go
even,
with this.
I've been watching other videos and chatting with MHL.
Oh, no worries.
So is the phi attached to the vertical line and the line from 110 to where R is pointing to?
Yes.
Alright, cool.
So, Joe was talking about how this is then cos, because that's just this line here. Z is just cos. But then from this point, and then we generate this picture, which would just be the xy plane. And I'm not seeing what I do. Green R dash is part of the shadow of circle gamma. In either plane, z-axis value of the circle shadow is unchanged. I'm very curious about this one. Put a picture in your Discord? Oh my gosh. Okie dokes. Oh my gosh. Alright. The one and only. Okay, so how much does this line up with what we were saying? So...
Okay, we very loosely.
Hmm. Okay. So that there is x10. Because you're following across... So you are following across to the point that it hits this line. Okay. And using that. This point here is... Hold on. One. X. So it's from... This is pound 4 because... It's on the line y equals x. Ah. Ah. Okay. Yeah. It's on y equals x. Is this the form that spherical coordinates take? But our theta is just known to be pound 4. Because that's how it varies across here.
Was that a question to me or?
Just out loud, I don't know. Like, if anyone wants to answer it. I might have a look back on that part in chapter 1 to, like, really... Because if that's what this, like, so all these projections are meant to, like if it's mimicking that sort of thing, then I should probably go back and have a look, and it might click a little easier. Because I can see this and be like, yeah, okay, that makes sense. But it's sort of like, it's not really gonna stick, I think. Even if it makes sense, you know. That's my problem. Isn't the answer? No. Okay. It's just being able to recognize how to identify x and y in with variance of no, okay, you figure out z here and then you're looking at x and y because you know that this point here is when y is set to 1. Right, this whole line here is when y is set to 1. Okay. Okay. Alright. I think... Alright, that's fine. Hold on. Get rid of whatever else. Yeah, okay, now. Okay. Okay, no, I think I understand now. That whole line across there is y equals 1. Right. Y equals 1. This is x equals 1. No, is it not necessarily? No. Wait. No, it's not necessary. I wanted to write x, y, and z in that terms of the angle phi. Right, okay. Reasoning is similar. Okay. That here is sine phi, yes. This makes sense as to why it's x. This is 110. This one... Is it because it technically lines up? So really, it should be more like... Like, where we're looking at a line across here, right? And that tracks up to the point where x... No. If x and y... X... This is x equals 1. That is y equals 1. Isn't it? No, other way around. Oh my goodness, Yoshi. X equals 1. So if you're continuing to draw a line from here out, then for that point, y equals 1. Okay. I can't coordinate system. Okay. But this is along y equals 1 because you're drawing a straight line. Okay. Right, so then x is just varying along this. That makes a lot of sense. And we know that this is 45 degrees power and 4 because of it being x equals y. So that's... okay. Oh my goodness. The goal I had in mind... Yeah. The x, y, and z values of that red point I highlighted, the arbitrary one in the circle. Yeah. This here. And you determine that position by still right. And the point down here is x, y, 0. But we have a way to vary z already. So it was still using the idea of like just going across this line. Like x and y just vary across this line, but it's understanding that maybe I should have drawn the line in 2D. Maybe that would have just made a whole world more sense to me. Like if we have Y here, I'm still drawing it red. Gosh, intense. And this is X. Point in this direction. Right. And you have a point here for X and Y. And this here is 1, 1. We have a line going through here. We have a point here. 1, 1. Right. And then we want to determine this point here. So what we do is since we know these values, we can mark across here, right? So that you could draw a triangle out from here or here. So we choose this one because why not? And this point here, just note that to be part 4. This point here, since it lies on y equals 1, it's a straight line going down here. It's then x. Because x, it's moved on from x, like we don't know where it is on x, and it'll vary depending on like how far we go from, how far we stray from here. Anime math time, so good. Right. So this depiction here is where we get this triangle from. Oh. Then x would be, so if this is 0, 0, 0, this would just be, cos. Anyway, right, this is the adjacent one. It would just be cos. Okay. Ooh. Right, and we've already moved out. This is where x equals 1 already. So it's 1 plus and then moving out from it. Cos part 4. Because the bigger this gets, the more x... Hold on. Was it smaller than... No. Which one's moving? This one, right? Oh my goodness. Right. Hey, Nate Bells. Yeah, even seeing this, I'm still like all over the place. I'm taking a bit. What? Was pound. The length of the hypotenuse is changing since 5 varies. The length of the hypotenuse change. Right, because this is still sort of like variable written. That's how we get a variance. Because I was like, this is just like x1 plus, and then this angle gives us this generally. But because of this varying, it's a multiplication. It scales. That's. I understand that it varies, but it directly scales against the cos pound 4. Xy should be largest when phi equals pound 2. So if I'm looking at this, phi. Yes, if phi is pound 2, then you're reaching this point and this point. Oh. Right, and because you're extending that outwards in that way, then this becomes longer in this direction. So you... And then y uses the same style of logic, except yeah, you're on this line, so it's sine instead, because it's opposite. No, that's still sine. Oh my goodness. You found the vector r in the parameter phi? Oh, nice. What's going on here? So, let's see. Right, x take 2 because you're moving along that. Plus z squared, right, because it varies up to z squared. Right, and you're looking at a plane. As a result... Ooh, that's that zoom. Right. From this situation. Okay. Yeah, you're moving out from this along. Okay. Gamma dash rotated 45 degrees anticlockwise. The value of the z-axis remains unchanged. Huh. That's fascinating. Very interesting. So then you... Oh my gosh, is this like rotational matrix business?
Yeah.
Oh my gosh. I forgot those existed. That is crazy. That's so cool. Ecstatic that my words are going over the... Nothing better than a found solution. The radius of the initial circle should be 1 and the answer matches mine. That's fascinating. Wow. Wow, 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 wow. That's so good.
Alright, I'll be back. I'm gonna go check on my noodle dough.
Absolutely. Oh, that's really impressive, Andy. Crazy good. Crazy good. I wonder how long I've been doing this particular question for. I don't actually know when we started this one. Hold on, when did we start? This one. Oh, I think that we've been on this one for like an hour. Oops. We'll be out of here soon. Finished my first class? Nice! Welcome back, Shocky. Is that the same problem? Yeah, I did not realize how much time had passed. But it's okay. This I think tomorrow I'll come back and like reevaluate this and see if it clicks more. Because I think I understand it enough, but I would never be able to come up with something like this. And so like the everything makes sense. But it, like you know what I mean? It makes sense, but it doesn't. It's not processing, I guess. For now, I'll use it to derive a result so we can get an answer to this, but I think I'll definitely revisit. Thank you so much for like drawing this all up as well, Joe. Very, very much appreciated. And Andy for submitting your result too. This is a really fascinating way to like look at the problem. Really, really interesting to see. Oops, jeez. Okay. Oh. Yeah, that's right. It is Radius 1 here. It's a bit evil. What question number is this one again? 20, right? 20. Part 1. Pick up another paint. Put this on part 2. Okay. F is minus. Finding like the bounds and the function stuff is really is the hardest part now. Everyone's like back in high school maths, a lot of it was just like, oh, evaluating this is crazy. And then like once you do multivariable calculus, you get into like oh not even multivariable, but like sorry, like higher level calculus. Like, what are the bounds, right? And what are the how do you change this order of integration? How do you substitute? How do you do like variable substitution to solve this? And then we're doing this where it's like try to figure out how to parameterize stuff, and like it's crazy. The setups for the problems are the hardest part, truly. Truly, it's being able to have the situation to map something to a set of coordinates, and then from that derive equations that you can use, and just like apply formulas, right? It's like doing a worded question without even doing a worded question. Like this is just raw maths, but you're still trying to figure out what it all means in a geometric way, how to solve for algebraically. It's rough, it's tough. Oh, but it's interesting stuff, definitely. Not a big issue? Yeah, absolutely. It is a very neat way to get it. I'm very impressed. It's so cool. Alright. That's that one. 2x. Oh, so z doesn't even end up mattering. you just need the definition of z in order to determine this. Oh no, wait. Do you need z at all? No, I guess to complete the transformation, it's correct to have that z. But yeah, okay. That's what it's a puzzle, pretty much. Change the value shadow vector by the condition that radius is 1 instead of quadrant 2. Exactly. Exactly. So good. 2 plus root 2. Sine theta. It's just x. 1 plus. dt is... Oh, sorry, it's not even dt. d phi. Minus sine. No, z is... blah. 2 on 2 cos theta. 2 on 2 cos theta. Minus sine theta. It's as simple as that. Now our line integral goes between 0 and 2 pi. So if we're going clockwise in that sense, should we be taking a negative if we're traveling counterclockwise? Because it's like doing No, direction doesn't matter with... Does it? Hold on. When does it matter? I remember reading up to a certain point and seeing that direction doesn't matter for something, and then it does matter at a certain point, but I don't remember where that came over. Yeah? Okay. So it would be negative, that I assume. But it was oh, it was orientation to do with these. And this was in which section? This is with surface integrals. So did it not matter? It doesn't matter if it's conservative. Oh, it doesn't matter if it's conservative. Okay. Yeah. Thank you. Thank you. So we're taking the dot product of these. Well, that's a bit... oh geez. Yeah. Take half sine plus had a good time, Yoshi, but I'd better start my day. Aw. Honestly, this has been more help than I could have asked for. Thank you so much for all of this. I will not keep you around for any longer than you have to be around. Absolutely, absolutely. Thank you so much. It really means a lot. Like, I would have just been stuck here for ages, and ZX... I don't know. I don't know how you'd be feeling about this either. I think we both just would have been in despair. But like, it means a lot, because Like this is stuff I'll be able to discuss with my friend. Like that's it's a funny thing. Like it helps me a lot, but if I can get ahead and get this help from other people, I guess, and then bring that help to my friends as well and whatnot, then I think it can make a good big difference. It's tough, but I'll get it eventually. Thank you. Suppose I'll catch you around sometime soon. If you want to continue hopping into these streams, then yeah, absolutely. I'll see you around tomorrow or whenever else is convenient for you, obviously. Have a good rest of the day, though. Thank you. Much love. Notify fixed my sleep schedule. Hold on a moment. Isn't it like 10? 10:15. Did you stay up? Hold on. Not if you fix it. I thought you were just waking up early and like, I don't know, like 8 or 9. And that's why you existed here early.
I am back.
What happened? Hello, welcome back.
It seems like we're on topic.
Pretty much. I would wake up at 6. What? Is this I would do this but oh my gosh. Recently, thank you for the raid. Hello everybody. Hope you guys are doing well. I was wondering like I would do this but something, or was it saying I would sometimes wake up at 6? Oh, do you mean wake up at 6 p.m? 6 a.m? I would wake up at 6. The English is black. It could be like I would wake up at sometimes on some days I would wake up at 6, and that's problematic because I wanted to wake up later. Like that could be the other way to interpret that, and I assume that's. Oh my gosh, I'm so confused. Ask questions you're not ready to handle the answers to Yoshi. Yeah, alright, later. Have a good one. It's okay, Shoki, though. You being around, like, people sticking around, the company is just. Rainbow, thank you for the. I mean, sorry, I'm getting myself there. We're getting tired. It's a raid message. Hi, welcome. Thank you so much again. Thank you for the follow as well. Oh, from both of you, Rainbow and Rosen, thank you. Much appreciated. Hope everything went well for you all. And very curious about like what you would be doing for like a radio math stream. It's very bizarre. It feels also math. Oh, well, I appreciate it. English is hard, it is. As there's no way I'd wake up at 6 a.m. Oh, I would wake up, but so that's the first option, right? But it's too difficult to. Okay, yeah, another thing. Are you looking? Have a good stream. Yeah, no problem, you guys. Thanks again. Very much appreciated. Yeah, no, I don't know. There's a lot of ways to read that sentence. Oh, well. Guess we'll find out next time, or never. We'll see Joe next when we see Joe. I think that's the easiest way to put this. Oh my goodness. Okay. We just have to evaluate this. Dot product. Root 2, where is out to? That's this one here. Take sine theta. Take sine theta, take root 2 and 2 sine squared theta. D theta. Why is this such a weird set of terms?
Doesn't a lot of it go to 0?
Let's find out. So this minus root 2, so what are the cos terms? It's this one and this one only. Okay, so that one becomes So that's 2 root 2 on 2, so that's root 2 on 2. Just positive root 2 on 2 cos. These ones are just half. Sine theta is just by itself. I don't know, this doesn't look like 0 to me. Oops.
As in, after you would agree to that, man.
Oh, yeah, no, that was reasonable. Take sine. Oh, it's... Yes, have a good one. Thank you. Okay. Sine theta cos theta has a thing, doesn't it? Sine cos. Density. Yeah, sine 2 is this. We can't, unfortunately, we can't take out something, so we can do the U substitution thing again. So yeah, we're gonna have to just deal with this separately. So this sine cos becomes sine half. It's half normally, and times that by 2, so it's just 1. No, I'm looking at this wrong. Oh, it's a quarter. This one is a quarter sine 2 phi. This one is... what is sine squared again? One take cos on 2. Root 2 on 4. 1 take cos.
Oh, the best kind of classes.
Fair enough. Sine. Take 1/8 cos 2 theta. Oh, phi, this is phi. Plus cos phi. Take root 2 on 4 phi. Plus half sine 2 phi. Between 2 points. Okay, equals minus, so the any signs go away. This is just 1. So that's 1/8. Take 1 plus root 2 phi on 2 blah blah blah. Now I'm going to take 1, which is plus take 1/8 plus 1, because it makes sense that the causes would cancel because even blah, and then that goes away. So the only thing that you have left, it makes sense here, is the term that's just a constant, which becomes phi, which becomes that answer. A lot of our answers have been having pies. They really like these. Oh, save. And that's it. I have no idea if that's right. Like the calculations again could be off, but I think the concept makes sense. I understand what the notation means now. So at the time of writing the notes, it's not very friendly, but knowing that it's just f parameterized and then your r is what you've made. Okay, so r is parameterization, f is just when you substitute in, and then you just derive r and take that dot product with f. Take that integral and you win. And that's it.
Yeah.
Time to find the next set so I can write them up on this notepad. We're not gonna do any more tonight, don't worry. It's bad.
That's good. You say we. I have done literally nothing.
Well, you don't have to
I
like
corrected something,
sit
didn't I?
and listen to this.
I don't have to do that.
No, you don't have to, because obviously it's an obligation when I'm doing it otherwise. That's how this works.
Yes.
We hold you here.
Exactly, I'm a hostage. Help, please.
Oh, but it's also of your own will, so it's sort of like, I don't know, maybe you
Well,
just enjoy
how much
that.
of it is of my own will, and how much of it is of my own will because of Stockholm syndrome?
You see, those are the questions we don't ask.
When did the Stockholm syndrome start? Was it when I started uni myself, or?
Again, this is not something you're allowed to be asking. This is like
did it
against.
start then, or did it start in like year 4?
No, this is
It probably started in year 4.
this is against our company's 2OS to start questioning things like this.
Oh,
Sorry.
speaking of company, I saw really early on in the stream that Hamburger said something about something me bringing food for the company.
Yes, that's right. You
Yeah,
agree to that, yes?
I'm sure I agree to that.
Exactly. Good job. Well
I'll
done.
ship some like of the hot cake to Hamburger. I could ship him Mentai cookies
Ooh, yeah.
because like they would actually ship because that was the purpose of them, to ship
Yeah.
biscuits to Europe.
Very nice. Just gonna double check if I wrote these out.
They also taste like a biscuit that you would expect can ship to Europe.
Yeah, fair.
Like they're good, but they're nothing like extravagant.
Yeah, that makes sense. Oh, isn't this exciting? So this is next week's stuff, which we'll tackle tomorrow. Stuff integrals.
But it's nowhere near next week tomorrow.
You're so funny. It's like 4 days.
Yep.
I'm
nowhere
like
near.
barely ahead
It's
now.
over half a
Look,
week.
look, I'm gonna end up at this rate. I'm gonna end up behind. Oh no.
Speaking of belly ahead, what's the Puyo tutorial schedule like?
Yeah, I don't know. I'm gonna have to like pick that up in the holidays. It just flew out the window after all of this. Like, I didn't expect this work to be so crazy,
Yeah.
but we'll see.
No, it's fine.
Actually, no, we might not be doing problems tomorrow. I might just be watching the lectures by myself. We'll see. It depends. It
I
just
have
depends on how long
no
those
idea
lectures
how
are.
much more around tomorrow.
How much?
Oh, hang on. Was that watching through the day or watching?
I don't know when I'm watching. That's the thing. Like, that's why I don't know if I'm
Right.
streaming more
Right.
tomorrow. We'll have to see. Okay, so let's see. That stuff is for next week. Physics and stuff I have to do soon. Probably I'll have another look at that tomorrow morning. And linear stuff that is okay. And then there's assignment work to do as well. Boy. I'm gonna smash through this slightly faster. No, I think this is a good pace. If I can get it done by like end of next week is week 10. Oh, that means I have to get through the rest of like the probability content too if I want to like actually dedicate the rest of my time to assignments rather than content. If I can. That's then we have elite week 11, week 12. Some assignments are due week 12. It's 2 weeks. and then calc as well. I don't know if that's enough time. See, even working ahead is not enough. Doesn't feel like. But I'll just keep trying. We'll see where it takes us, I guess. We'll know when we get there. We got through a lot of questions today, though, to be fair. Did we complete the whole of this week's set? I think that was. I think it was literally all of this. That's nice. Thanks again, like Joe, lifesaver. I definitely would not have been able to otherwise. Goodness. There is a decreased question count for the next couple. For the last few, like this is how many questions is it left in total? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't know how much applying theorems would actually have in them, so we'll see. We'll see. Very mysterious. That's done, that's done, that's done, that's done, that's done. It was good to close that off. What is this paint that I have left over? Ah, yes, that's just the first part of the question. This is for next time. Yes, save. That's it. Freedom. For the night. Well then. We shall meet again soon.
We're gonna watch an MHL video and
Oh.
no, that fail.
Yeah, I think I'll head off with it tonight. We'll have to soon.
Yep.
Have to soon. Remind me.
Yep. Yep. Before we watch the like egg game and we watched the documentary, sushi documentary.
Ah.
Roughly the same length.
Okay. Fair enough. Fair enough. What was the other video again? The shorter one. It was.
Oh, it was the Orange Line Western Record.
Oh yeah. We can watch that like next time then.
Sounds good.
Yeah.
I have watched it. I felt bad saying, "Is there a whole bunch of time save in there to him?" Because obviously it's a good game, but it was also so sloppy and low G.
Okay. It's an
And
interesting
he made
thing.
one terrible decision.
Oh, okay.
It just like, yeah, he cleared a Tetris at the wrong time. And like, just the level stop. Well, not really a level stop. He had to set his stack up in a weird way so he didn't get level stop, which ended up with a whole bunch of singles.
Right. I see.
And if he just didn't take the Tetris, and he would have been fine.
Lost some time then?
But yeah. Yeah, just a little bit, like maybe a second or two.
Oh, okay. Yeah, fair enough.
But yeah, like I sent him a message and be like, "Is that time saving?" It's like, yeah, it was garbage run.
Yeah,
That was
yeah.
basically what happened.
You could just one-shot it.
I don't know, like how many times he like played. I know he was practicing the Emerald the other day, but
Oh,
I don't actually know if he's
interesting.
been working towards it or not.
right. No, that's interesting. Crazy good. Oh no, the P one. Yeah, a bit yawny. Alright, sounds good. Thanks for hanging out, Bruno. Enjoy the sunlight. I'll be doing the opposite.
Yep, moonlight.
Yes. Well, I mean,
Going
I
outside
don't really
and,
want it to shine in my face when I'm trying to go to sleep.
Do you sleep with your window, like your blinds opened or closed?
Nah, closed.
I occasionally, like, if I need to get up, I'll sleep with my blinds open so the sun wakes me up.
Ah, yeah, no, that's fair. That's fair. Yeah, that makes sense.
And then if you see the sun come up before you go to sleep,
Definitely the
"Blinds
blinds are
closed
closed.
now."
Yep. Xenix problems, right?
I went to bed early last night, like 2:30 or something, right?
Yes, fair enough.
And then I woke up at 8 this morning. I naturally woke up at 8. because I knew I had so much to do.
Oh, that's crazy. That's like me with exams, except I end up waking up at like 5 a.m. and being scared that I missed
Yeah.
the exam because I had a
Oh,
nightmare about it. Oh boy, I've
yeah,
talked about this on stream, I'm
yeah,
sure.
yeah. I have similar dreams.
Yeah.
Like last year when I had a meeting with the like head of school after quitting,
Hmm.
I like could not get to sleep that night because I just kept waking up, um, like stressed I'm gonna miss it.
Oh my goodness. Do you end up having like
I
nightmares of it?
barely slept.
Oh, so you
Like,
didn't even get the opportunity to.
yeah. Uh,
At least there's that.
but I still have like nightmares about school and stuff. Hey,
How so? Is it about
just like
lateness or just random junk?
just random drunk.
Nah. For me, it's only ever in regards to being late or like something silly like that. I think lateness is probably one of my biggest fears for some reason. Like one of my very, very subconscious thing. Because it always just
Yeah,
comes up in dreams, and I swear I don't remember like any other dreams I have now. These days
yeah.
I
No.
do not remember anything. And it's just the lateness dreams.
I had a dream about like making ramen the other day. Like I was so excited about it.
That's great.
Oh, also my ramen dough is a bit dry. Should I just add like 3 liters to it?
Oh, that's how the guy did it, and he's like
Yeah, yeah,
professional, so you know.
yeah, yeah,
That's how you
yeah.
do
Right? Yeah, that's. I definitely don't know more than what he does about making ramen.
it. You know what you're doing. It's okay.
Yeah. No, it's just very deliberately this dry.
Yes, very nice.
It's like, oh, 40%. It's a little dry. It's like,
40%.
really? And then you're gonna add water to that. You're making ramen there, or?
No, it's trying to come up with something funny. Oh well. Not ramen. There you go. Haha.
Yeah,
So
definitely
funny.
does not feel like ramen. That would not fly for ramen in Japan.
Yep, that's fair.
Alright, bedtime, I guess.
Yes, alright, I'll hop off stream for now. Thank you all again for hanging out. It's been nice to be able to chill. Very I don't know, maybe it's good for other people to study. I don't know if you're working or something. It's just it's good. Also, like Joe's still our hero. I'm gonna have to like start putting his name on the somewhere to like credit him for literally everything.
Like the VIP list.
Yeah. Oh my gosh. Yeah. That way, when he comes into chat, people are like, "Oh, this guy's important."
Yes.
So that's what that means. So
Like
good.
me, I'm important.
Yes, very important. You, you talk about important subjects during very important moments in my gaming career. Yes,
Yes.
very good. Alright, you guys have a great rest of the day or night. I love you guys, and I'll see you all next time, which will be maybe tomorrow, but if not, then most likely I'll still be streaming on Friday. And it might not be homework on Friday. So, I mean, look forward to... I need to get world record back. Maybe that's what it will
You
be.
do need to get world record.
We'll see how it goes. Alright, see you all next time.